A confirmation about the audio, please, guys, if the audio is available. Thank you. I'm feeling much better. Thank you for all the kind words and the kind mails that I've gotten. Thank you very much. Doing much better. Monsoon trough is basically referred to the low pressure cells which develop due to intense heating. That will attract winds which will cause rainfall. So that is monsoon trough. International boundary is roughly around 12 nautical miles, but it is not as if there is coastal erosion in an area. International boundary, see, coastal erosion, when you talk about coastal erosion, few meters here and there, they may be taken up here and there, but overall the shoreline, it is taken as a straight line. So if in an area, let's suppose the coastline is like this, so in order to calculate the nautical miles from here, you will consider this to be a straight line, and you will consider 12 kilometers from here. It is not as if 12 kilometers from here, 12 nautical miles from here, like that. No. So you have a straight line from which it is drawn. Okay. And regarding the question that if you have two countries, both of them are in the coastal space within 12 nautical miles, it is divided in that case. Okay. Thanks for all the kind wishes and the kind words, guys. Doing much well today. So thank you very much. What creates pre-existing low pressure in cyclonic season of April and May, and this time even in June? It is the heating of the water body. Over a period of time, there is heating of the water body which happens, due to which the temperature starts increasing. For example, even this time when Biparjoy is developing, it is expected that the temperature of the Arabian Sea would be somewhere around in the range of 30 degrees Celsius, plus minus 2 degrees. So that means you will always have a pre-existing low pressure system around that region. And in certain areas, if the temperature starts rising up, that is where the disturbance develops. Biparjoy is the tropical cyclone. Kindly take a look at the portion of current affairs. All that you hear right now is the portion of Biparjoy. Chaitanya, what would be the effect of sudden arrival of El Nino on this year's monsoon, and what on the next year's? So basically, see, when we say El Nino and the impact of El Nino won't arrive in India. Its impact would be felt because that is something happening in the Pacific. So its impact would be felt by weakening of the mascarene high, and that is expected to happen somewhere in the month of July, August. So in the initial month, it is expected that the rainfall would be good enough. So especially those areas which receive rainfall in the first month of monsoon itself, within the first 15 to 20 days, they would experience a good enough rainfall. And then El Nino would have its impact where the amount of rainfall would reduce. So, for example, regions in the northern part of India, northwestern part of India, those are the regions this year which are expected to have very little amount of rainfall. Yes, Biparjoy has been named by Bangladesh. Next naming is to be done by the name taken by India. So, next cyclone, take a look at the list, you will get to know the name. Okay. El Nino impacts our agriculture by weakening the amount of rainfall, leading to crop failures. Why Biparjoy is changing its path? Biparjoy basically understand that it changes the path followed by a cyclone is a multitude of, or an outcome of, two important factors. One of the factor is it gets attracted towards the low pressure, the wind system, as it moves it moves along with them. And secondly, you will find that there is a Coriolis bending as well. So sometimes if the low pressure, let's say, is here, cyclone is attracted there, but then there will be a Coriolis bending, cyclone will end up reaching there. That is what is referred to as the recurving of a tropical cyclone. So that is why observe the path taken by Biparjoy. You will find that it is coming towards the ITC set. That is the extreme low pressure. All the winds are bringing it to the ITC set. Then there will be curving here and there and slight deviation depending upon the low pressure. Shreyank, in tablet video, you said that motion of Earth in west to east initiates equatorial current. Here also I have told you, if you look at the recordings of the video, here also I have told you that the motion of the Earth, the rotation of the planet from west to east direction in general brings about a inertial movement of wind, slight movement, what we refer to as equatorial westerlies. And here also I have told you that initiates a slight motion of the water. That is what is referred to as the equatorial current. Yes, you have to learn the impact of ocean currents. But you said their direction is from east to west, then how they are able to hit Gujarat. So listen to this very carefully, guys. The aspect regarding the tropical cyclone, the direction taken by tropical cyclone, please understand, we had talked about that how tropical cyclones, they are impacted by the low pressure systems, right? Or they are basically, their direction is taken by the direction in which the permanent winds exist. So listen to this or understand the aspect what is happening in the case of Biparjoy. So here, assume that a low pressure center is created in this region, southeastern Arabian Ocean, Arabian Sea, let's suppose. Now, what are the winds which are in existence at this point of time in the year? That is something you have to keep in mind. As of now, what are the wind systems in existence here? As of now, the wind systems are basically like this, isn't it? We have the southwest monsoon season and the ITCZ is like this. So that is why this cyclone takes a path and will hit Gujarat and Maharashtra. Okay, so it is moving towards the ITCZ. I hope that is understood. So prevailing winds are the ones which will influence them, and that is how they end up moving. So having said that, now let us initiate the discussion about the physiography of the country, and then we will move ahead with the drainage systems. Okay. So here, when we talk about the physiography, we had basically talked about the aspect of the Himalayas, the features associated with Himalayas. We had talked about the northern plains, the formation of the northern plains. We had also talked about the desert, its formation, and also the formation of Peninsula Plateau. So very briefly, we shall be covering the portion of Peninsula Plateau again, and then move on into the portion of the coastal plains and the Ghats region and the islands as well. So when we talk about first, for example, the Peninsula Plateau. Now the Peninsula Plateau overall, understand what is a plateau. Plateau is like a flat tableland like structure. So plateau, when we talk about, it is somewhat like this. It will have a slope in any particular direction, but it will be a flat tableland like structure with steeper sides. The sides and the slopes will be steep. That is the characteristic feature of a plateau. Now, plateau mostly across the globe, you have different types of plateaus in existence. Most of the plateaus that you will find, they are created either due to volcanic eruption, where volcanic eruption keeps on piling material layer upon layer, they solidify, form a piled up structure. So either by volcanic eruption they are created, or in many of the cases, the land simply gets uplifted, and land gets uplifted creates an elevated structure. For example, when we talk about Tibetan Plateau, even though the formation of Tibetan Plateau is much more complicated than a simple uprising of land, but Tibetan Plateau, in a very nutshell, in a very brief manner, if you have to understand it, Tibetan Plateau would not have been created had the Indian and the Eurasian plate not collided. The collision of the Indian and the Eurasian plate created that kind of a reverse fault, and the further compression simply uplifted the land. And after a particular height, the land simply started to move away and expand. So the Tibetan plateau is a bit complex, but when we come to Peninsular Plateau or the plateau in the southern part of the country, that has been created as a result of volcanic eruption. So that is why in the Peninsular Plateau, you will find the dominance of igneous and metamorphic rocks in general. These are the dominant rock structures. And these igneous and metamorphic rocks, over a period of time, when these rocks they will cool down, the rocks will have some amount of minerals here and there which are situated as well, isn't it? Igneous and metamorphic rocks we will study in a couple of classes. When you have the igneous and metamorphic rocks, many of the times the minerals they are embedded between them, within the cracks which develop within the igneous rocks. Many of the times you have minerals which would have gotten into them at the time of solidification itself. Now these igneous and metamorphic rocks, they have created this particular plateau close to around more than 2 billion years back. And that is a long time ago. And it is at that point of time where fragments of this peninsular plateau started being created. And eventually you had the entirety of the plateau formed. And that is when we have to understand that something which has been created to almost 1.5 to 2 billion years back, obviously the amount of weathering and erosion which would have happened would have been tremendous. Everything on the surface, excuse me, everything on the surface would simply have been taken away. Now, that is why it is in these areas where you will find that the bottom layers, which would be rich in minerals, because many of the times when you have the volcanic rock formation, igneous rock formation, it is not as if the minerals will start appearing at the surface itself. Many of the minerals are impregnated and hidden deep within the rock structure. So when the top rock structure has been eroded, weathered, and carried away, now the bottom layers they are exposing themselves, and now the bottom layers are something which is available to us, and that is why we are able to extract so many mineral deposits out of them. So that is why various parts of the peninsular plateau they will be found to be very very rich in terms of the mineral deposits. Now here, as we had talked about, as we had had a discussion about it, that the entirety of the peninsular plateau was never created in one go. It was never the case that one volcanic eruption spread in a triangular manner and voila, you had a creation of a peninsular plateau. No, that also happened in phases. So you had small building blocks which were created. And here, that brings us to the brief concept. For example, when you talk about the entire continent, let's suppose a continent of United States or continent of Africa. Now, when you imagine in your mind, now you know geomorphology enough to be able to think about that how continents would be formed. So, when you think about it, how do you think these continents are created? Will they be created at one go? There's a volcanic eruption, so much of volcanic eruption that entirety of Africa is created? Never. Never does that happen. So, what happens? Basically, you will find the formation of small masses of land at one go. And slowly and steadily, many of these masses of land, they will come together to form a smaller land mass. And slowly and steadily, that grows up to build a smaller, let's say, a subcontinent types. And many of these subcontinents, over a period of collision, divergence, convergence, they end up creating continents. So these building blocks of the continents, they are something referred to as a craton. That is building block of continents. That is something which is referred to as a craton. So It is just a name given. Many of the cratons make up one continental landmass or one larger landmass. Now, here, when we talk about the Peninsula Plateau, here again, I will quickly recap the things that we studied on Friday so that you have a quick recollection. So, the entirety of the Peninsula Plateau was not formed at one go. In fact, few of the researchers as late as December 2021, they have indicated that the region of Chota Nagpur Plateau, particularly near Singhbhum, that might very well have been the oldest landmass created across the entirety of the planet. Based on the evidences of the rocks, that is the conclusion that they have come across. It might not be true, but it definitely is one of the oldest landmass in the in our country. So here, when we talk about it, initially, you had the formation or the creation of the Chota Nagpur Craton here. That Chota Nagpur Craton got created due to volcanic eruptions, right? Chota Nagpur Craton. Then, after that, or simultaneously, you had the formation of another plateau region here, and that was the Bastar Craton. Then the region of Bundelkhand and the Aravallis, they got created. And at that point of time, Aravallis would extend significantly further north and they would have a greater height as well. Remember, we talked about how the Aravallis were amongst the old fold mountains, and at one point of time, they had such a great elevation that the peaks would be covered in snow and you would have massive glaciers originating from the Aravallis. So they would extend all the way to the present day region of Haridwar, right, all the way from Delhi all the way to the region of Haridwar. So the Delhi ridge that you have, the upended or uphill structure around the region of Delhi, especially the southwestern part of Delhi, so that uphill structure, that is a part of the ancient Aravallis itself. Okay, so that is basically the region of Aravallis and Bundelkhand, right? You had the Bundelkhand Craton. Then here you had the formation of Karnataka Plateau. Okay, so these were the individual building blocks which were created initially. And at that point of time, slowly and steadily, eroded materials from these building blocks, they started filling up the spaces in between. And that led to the formation eventually into sedimentary rocks over a period of hundreds of millions of years that got converted into metamorphic rocks in many of the areas. In many of the areas, you had minor volcanic eruption creating a small piece of land. So there was always this kind of a formation across these as the basic framework. These particular plateaus that you see, these were the basic framework. It extended all the way till here, extended significantly across the west as well. Now, this continued to stay like this for many hundreds of millions of years and evolved like that. You had multiple rivers which had already started originating from here. It was roughly around 90 to 100 million years back. While India was traveling northwards from its position in closer to the southern hemisphere, India was traveling northwards to come to its present situation, to come to its present position. That is when it crossed the Reunion Island volcanic hotspot. Reunion Island hotspot. Now, Reunion Island, situated in southern part of the Indian Ocean, that hotspot is an important and an ancient hotspot, and that had been spewing lava out for many years, millions of years altogether. Just like you see Hawaiian hotspot right now, you would observe that Hawaiian hotspot erupts quite frequently, brings out a lot of this magma, a lot of this lava out. And from this Reunion Island hotspot, you had the flow of basaltic lava. Basaltic lava. Okay, so think about it. If you have the entirety of the region like this, if this is the planet, this is the equator, if this is the present position where the country is fitted in. So as the country was traveling north, as the landmass was traveling north, right? Suppose this is where the Reunion Islands is. The western part of the subcontinent, that lied over the Reunion Island hotspot. That lied over the Reunion Island hotspot. And when Reunion Island hotspot was present, it was the western portion of the country which was lying above it. So over a period of time, you had multiple eruptions. And obviously, the Indian plate, it is not going to be like a metro train that it had a brief moment for a few seconds and then it will cross over. That is not going to happen. It is a large landmass moving at a speed of around 15-20 centimeter per year. So, in order to cross over an entire region of hotspot, it took around millions of years. So that is when initially, as they started moving, as the Indian plate started moving, it was moving over the region of the Reunion Islands. Reunion Islands erupted. And it did not erupt for one time, it erupted for millions of years at that point of time. And it with every eruption, you had materials which spread out. Let's say one eruption followed the another one after 5,000 years or after 400,000 years. It would spread over the previous one. And because it was basaltic lava could spread very easily. The basaltic lava could flow very easily, could spread very easily. So as a result of that, you had the formation of a layered format, layered solidification of volcanic materials. And this layered solidification gives you a kind of a terrace-like feature on the sides. If ever you get an opportunity to maybe travel by the Konkan Railway is one of the most picturesque railway routes that you will encounter, especially during these months, that is the rainy season. You should always avail that opportunity if ever you get that. Otherwise, if you end up traveling, let's say between Mumbai to Pune, Mumbai to, let's say, Nashik, you come across the Ghat section, the Kasara Ghat section, etc. Now, there, if you observe the Ghat section, on the sides, you will be able to still observe that layered format. All those high elevation hills that you see, that has got the layered formation, which indicates to you that the volcanic material would have spread over and they would have had a significant thickness as they spread over. So on the sides, you get a kind of a step-like feature in between these layers. And this step-like feature, that is what is referred to as trepan, right? Trepan refers to a step-like feature. And it is from this trepan that you have the term traps derived. And hence, the entire region where this happened, this entire region where this happened, that is referred to as Deccan traps. So it is basically these traps which the famous Deccan traps, as they are referred to, they are very rich in this basaltic lava rocks which are present. Okay, so they are very, very rich in that. And here you will find that between the various layers of volcanic material, many of the minerals are trapped. In many of the cases, water is trapped. So that provides a unique feature to the Deccan traps, which generally you don't come across. But nonetheless, in many of the areas, you have many kilometers worth of lava deposits. It is expected, it is estimated that at the time when this eruption happened, the Reunion Island hotspot in that entire time duration, which spanned for a couple of million years and a few thousand years, definitely. So, in that time duration, when the Indian landmass was over the region of the Reunion Island, you had such a massive eruption that close to around 1.5 lakh kilometer cube of molten material, 1.5 lakh kilometer cube of molten material that was actually pushed out. And that did not mean the end of it. So that material solidified. A lot of that material constitutes the present day Deccan Plateau that you see. But that was not the end of the eruption. The eruption basically had a lot of material inside it that it wanted to throw out. Right? So, what happened? There were certain complications which developed. So let's suppose understand the process with a very simple aspect, and then we will put it on a larger scale. So let's suppose there are these eruptions which have happened, and these eruptions, they have deposited layer after layer of this volcanic material. Now after this, let's suppose this region has become maybe 2 kilometers, 1.5 or 2 kilometers of volcanic deposits, igneous rocks. Now, after let's say 2 kilometers of this volcanic deposit, do you think this particular region here, it would be easy to break for the volcanic material? Will this surface be very easily broken, or will this surface be very hard and very tough to break? What do you think? Will it be very easily broken, or will it be hard and absolutely impossible to break? Right? That is what the logic tells us, that it will be very hard, it will be almost impossible to break. Beautiful. Now, what happened here after a point of time? So, you had the volcanic eruption which started happening in the Reunion Islands even after the entire Deccan traps were created, and material, molten material, wanted to come out. But then already you would observe that the entire layering had happened. So for the molten materials to break from this region was almost impossible. So what ended up happening was, imagine that this is the deposits of lava, deposits of igneous rock, and here is the western side where you have thick deposits. This particular portion, the western side of the Deccan Plateau that you see on your map. Now here, molten materials, they wanted to come up, they could not. So in the process, what they did was they provided a kind of a push, and with that push they started solidifying. Right? So it was a kind of an intrusive igneous rock formation which happened, but that was preceded by a push where the molten materials wanted to push and break through the surface, but the surface already was very hard. They could not break it. So instead of that, what happened was that the push provided a kind of a slope. Many materials started solidifying underneath without cracking the surface. And that is when the slope of the Peninsular Plateau overall had a kind of a feature. from west to east. You had a slope. And that is basically why that is created, because of that upliftment of land which happened. And it was at that point of time when this upliftment was happening, you had in the entire process lot of cracks which were created. In the entirety of the region of the Deccan Plateau, a lot of cracks were created in the process. And cracks would be created automatically if the land is pushed in certain direction. It does not want to move in that direction. So that is where cracks were created. And that is how the Peninsular Plateau was created. But initially, the shape of the Peninsular Plateau was very different from what we see today. The extent of the Peninsular Plateau, even though extends all the way from the Delhi Ridge in the north to the region of Karbi Anglong and Shillong Plateau in the region of the east. But today, we don't see an adjoining landmass linking Chota Nagpur Plateau to the Meghalaya or the Shillong Plateau. You have a lot of gap in between. You have the state of West Bengal and the country of Bangladesh in between. So you have a lot of gap. So how did that happen? So this also was initiated at the time of convergence between Indian and the Eurasian landmass. And try to understand it carefully. So here, when the Indian landmass, imagine an image like this. So when the Indian landmass rather moved ahead for collision, moved ahead for the collision, and the collision of the landmass, that is going to be a very strong process, that is going to have a heavy impact. It is not that softer materials are colliding. You have very heavy land masses which are going to collide with each other, so it is going to have a lot of impact. So as a result of this collision, you had cracks which developed. You had development of cracks in the east as well as along the western side. The cracks developed. Why? Because of the impact of the collision. Okay, I will repeat again. As the Indian landmass was moving and collided with the Eurasian landmass, the impact was so significant that cracks and fault lines developed, both across the eastern side and the western side. The collision happened slowly and steadily, obviously. And slowly and steadily, these portions, the cracks that you see, they simply subsided. They underwent a kind of a subsidence. They simply sunk. Because if you have an entirety of the landmass moving like this, and there's a crack which developed here, so the other one will simply fall down. So that happened in two places, here in this region and in the present day area here. So in two places, the land simply sunk down, the land went down. Now, in the region of the present day Bangladesh, as the land went down, that made the Meghalaya plateau discontinuous with the rest of the Peninsular Plateau. But Meghalaya Plateau has always been a part of the Peninsular Plateau. But that made it discontinuous. And slowly and steadily, the Himalayan rivers, which had been accumulating in the plains till that point of time, with the land here getting depressed, all the Himalayan rivers, that is Ganga, Brahmaputra, and the smaller ones here as well, all of them, they found an exit path. And all the Himalayan rivers from this region, they started draining into the Bay of Bengal. Had this crack not been created, had the land not sunk, the movement of the rivers could have been quite different. Now, as the river started flowing from there, the river started depositing a lot of materials as well in the process. And this material deposit which started happening, This material deposit slowly and steadily created the fertile plains that you see today in the region of West Bengal and Bangladesh. So that is a gap which has been created in the existent peninsular plateau, and that gap is now filled with the deposits of the rivers. This gap which is created, this is what is also referred to as the Malda Gap, or the Rajmahal Garo Gap. Garo Gap. Why Rajmahal Garo? Rajmahal Hills is situated here, the easternmost extent of the Chota Nagpur, northeasternmost extent of the Chota Nagpur plateau. That is where you'll find the presence of Rajmahal Hills. And here you have the region of Garo Khasi, Jaintia, and the region of Meghalaya. So the Rajmahal Garo Gap in existence. Meanwhile, something very similar had happened in the Western Ghats as well, in the Western region as well. In the western coastline, you had a significant proportion of land which underwent subsidence. Why? Because a crack had developed. And that is the reason why, till today, you will observe that despite the steep features across the coastline, the continental shelf across the western coastline is very, very wide. Why? Because significant portion has actually sunk down and is underneath the Arabian Sea. So that has formed the portion of the continental shelf. This is the reason why continental shelf is such wider across the western coastline. And this is also the reason why across the western Ghats you will find that it is an escarpment created due to a faulting, but the features of the western Ghats are almost straight wall-like feature. That means you had some land here, that land simply underwent subsidence, and now you are left with a steep wall-like feature. So that is, in a nutshell, the entire formation of the region of the Peninsular Plateau. Okay, if you know the formation of this, let me tell you how it will help. If you know the formation of this, obviously, here, if someone asks you which are the older regions of the country, the oldest regions of the country, I hope you won't find it difficult now, because which are the older ones? Chota Nagpur, Bastar, Karnataka Plateau, Bundelkhand, and Aravallis. These are the older ones. Now, we have talked about why mineral deposits are being found in Peninsular Plateau now, because for billions of years these have been in formation. So for billions of years, the top portion has been eroded away, leaving the mineral rich bottom areas for us to explore. So now if someone asks you, what are going to be the mineral rich areas of the country? I hope now we have the solution. Chota Nagpur Plateau, Bastar Plateau, Karnataka Plateau, Bundelkhand, and Aravallis. These will be typically dominated with minerals, right? Why? Because these are very, very old. That is why in minerals and industries, when you come across the mineral distribution for any kind of mineral, you will find Jharkhand, that is the part of Chota Nagpur, Chhattisgarh, part of the Bastar and Chota Nagpur, both of them, Odisha, part of both of these plateaus, the region of eastern Madhya Pradesh and central Madhya Pradesh, the Bastar Plateau region, the region of Bundelkhand, Karnataka Plateau, and the surrounding areas of Telangana and Goa. These are basically the regions where you'll find majority of the minerals distributed, majority of the mines situated in that region itself. Okay, so this also helps you understand the aspect of soil formation and the soil distribution. Now, igneous and metamorphic rocks, we will study later. Igneous and metamorphic rocks, they will basically break down to form red and yellow soil. Whereas the volcanic basaltic lava that you have, that breaks to form black soil. So now that you know the formation process, you'll be able to recount where is it that you have the black soil, where is it that you will have red and yellow soil. So when we talk about the soil and forest, there that will be a kind of a reinforcement for you guys. Okay. Now, okay, is southern Bihar also in Chota Nagpur Plateau? Yes, parts of it. Pulkit means entire Peninsula Plateau doesn't got its deposit while passing over Union Islands, and they were already. Yes, that is correct. Are minerals not found in Deccan traps? Not a lot of them, Ritika. No, because these are still fresher eruptions. There are some minerals found on the edges of this plateau, but not bam in the central middle portion of the plateau. Vechri will come to it. If the slope of the plateau is from west to east, how we have two westward flowing rivers, and how ghats are formed. Vechri, I'll come to that once we understand the entire process. At the end of the session, I'll ask you the same question. I'm sure you will have the answer. But please understand, if the slope is from west to east, your question is how come then we have two west flowing rivers, but we have almost all the other rivers which are east flowing? Doesn't that give you an idea that the slope would be from west to east? So there must be certain anomaly present in those rivers which are moving to the west. That is something we'll find out slowly. Don't worry. Okay. And how these four plateaus are formed around the Deccan Trap due to volcanic eruption. Volcanic eruption which happened long time back. Malda, there is no meaning of Malda is basically a place, a district in West Bengal from where this gap exists. Northwestern Rajasthan has got fossil fuels. Yes, crude oil and natural gas, shale gas also. Why does Western landmass so wider? Western, if you are asking about continental shelf, the Western continental shelf is wide because significant portion underwent subsidence as it collided. Okay, I hope that is clear. Bastar Chota Nagpur Plateau are formed of volcanic activity. Which time, as they were not formed Reunion Island hotspot, please tell. Bastar Chota Nagpur Plateau formed of volcanic activity, or which time as they not formed. So at what I'm trying to get the gist of your question, Shalu, is basically by the time you had the formation of, or you had the entirety of the region coming over the Reunion Islands, by that point of time, Bastar, Chota Nagpur, Karnataka Plateau, Bundelkhand, etc., they were already in existence. And they were in existence because of the eruptions which happened, and you had the formation of these small individual craton like formations, or the individual plateau like formations. Just a moment. So you had the small plateau like formation in the region of Chota Nagpur, Bastar, Karnataka, and these were all volcanic eruptions which happened billions of years ago, long, long back before the Reunion Island event happened. Okay. Traps are derived from trepen. Trepen refers to step-like feature. So on the sides you have step-like feature, hence it is referred to as traps. And Malda Gap is not part of the plateau anymore because that gap is having deposits. So it is not part of the plateau. Were there cracks in Indian plate through which volcanic eruption came out? Obviously, yes, when you are over a volcanic hotspot in the initial stages, and if you don't have a lot of deposit over them, it will break out, it will come out. Okay, just because subsiding of land on the western side of the Western Ghats erupted, Ritika, there was no eruption. After Indian plate moved to the north of Reunion Islands, there was no much eruption which happened. Due to the collision, as there was development of a fault line, that is why, and there was no compression which was happening, hence the land got subsided. Malwa Plateau is in existence. It is in the region immediately to the south of Bundelkhand. That is the Malwa Plateau. Please don't get confused between Malwa and Malda. Please never get confused between Malwa and Malda. Malwa region is in the region of Madhya Pradesh, western part of Madhya Pradesh. Malda is in the region of West Bengal. Garjat Hill Ankur got created as a result of this Chota Nagpur and the Bastar plateaus, they coming together and they colliding. Reunion Islands are still situated where the Reunion Islands are. That is why it is referred to as Reunion Island hotspot. And I'd asked you guys humbly to locate it on a map. I don't know how many of you have done that. And what is Deccan? Deccan is basically uh, Deccan is the region to the south, in the southern to the south of Narmada in general, and is derived from the term. If you have read history, I'm sure you would have read history. It is derived from the term Dakshin, Dakhin, and from Dakhin you had the derivation into Deccan. Bastar Plateau also have a trap-like feature. No, Bastar Plateau doesn't have a trap-like feature. Okay, is that clear? Elias, is it only due to the volcanic eruption we have the west to east sloping? Yes. Okay. Reasons for formation of the Delhi Ridge. So that had at one point of time it was the Aravali ranges which spread all the way till Delhi. So the Aravali ranges over a period of time, as soon as the folding stops, it is the exogenic or the external forces which start dominating, and that is when the hills and the mountains they keep on getting degraded their height over a region significantly smalls down or lowers, and that is why the Aravali Hills in many areas to the south of Delhi, they have been reduced to a kind of a ridge-like feature. So that is basically the formation. The extent of the peninsular plateau, if you will observe. So in the northern extent is the Delhi Ridge in the northwest, Rajmahal Hills in the east. So the Delhi Ridge, that was a part of the old Aravalis, that is in the northwest. Rajmahal Hills, we have seen. Where is the Rajmahal Hills? This is where the Rajmahal Hills lie. This is where the northern plains we have seen are at their narrowest. Gir ranges in the west. This is where you have the Gir ranges overall. And then Cardamom Hills to the south, Shillong and Karbi Anglong, an extension of the Peninsula Plateau. So this is the overall extent. And overall, on the broader aspect, if you think about the Peninsula Plateau, it can be divided into three zones, three regions. You have the Deccan Plateau, the Central Highlands, which includes the region of Vindhyas, the Satpuras, the Rift Valley system created by them, then the Kaimur Ranges, the Maikal Hills, the Garja, the all the central portion that is included, the Garjat Hills included, all of them are included in the Central Highlands, and then you have the Northeastern Plateau. But what you need to be figuring out after looking at the atlas, I don't know how many of you, I had told you guys to look into the atlas for physiographic divisions of the country. How many of us have managed to do that? Tushar will come to it, don't worry. Okay, good. Very few have done this, but nonetheless, I never expect large majority to do this because this requires a bit of a discipline. This requires a bit of a meticulous nature. And please understand, it is these inculcation of good habits slowly and steadily that builds into discipline, which is the differentiating factor between someone who has qualified and someone who keeps on analyzing the question paper year after year. So get that difference, get that habit, which is very good. Good and happy for you guys. So here, when you talk about the entire plateau region, the plateau region has got multiple different portions, sub portions overall, because they have not been created at one go. They are not homogeneous in general. Rahul, when does Indian landmass collide to Eurasian landmass? What happens? Formation of Himalayas happened, Rahul. And in the case of the Peninsular Plateau, the land here subsided, and here also the land subsided, creating a kind of a shape that you see of the Peninsular Plateau. Now here we have the Aravallis in this region, extending all the way to the region of Delhi. And then here you have the Malwa Plateau. Malwa Plateau, by the way, also does consist of black soil formation. So the Deccan Trap feature would have extended or would have spread over even in this area, it is expected. Then here you have the Bundelkhand. In this region, you have the Bundelkhand. Right? This is Malwa. This is map pointing for you guys. This is Bundelkhand. This is your Vindhyas and Satpura. Okay. Here you have another hilly area or plateau region. In this area, another plateau region exists, and that is referred to as Central Uplands or Madhya Bharat Pathar. Then here you will come across Baghelkhand. Then here you have the Chota Nagpur Plateau. If sometimes you are interested, sometimes obviously you have a lot of busy schedules in your life, you'll have to meet the Prime Minister, the Home Minister, the Cabinet Secretary, the Chief Secretary. But if sometimes you have some empty time in your busy schedule, try to find out how the naming has happened. That in itself will give you a lot of insight and information. It is generally named after the tribes in that region, most of them. So if you find out sometime some amount of time in your busy life, try to get to the deeper part of it. You will obviously find a lot of interrelation. For example, in the region of Bundelkhand, Baghelkhand, which people lived there, what has been the historical tradition, that is always enriching experience. Then here you have the Chota Nagpur. Here you have the Raj Mahal Hills. Here you have the Bastar Plateau. I'm showing the rough images here. Here you have, this extends furthermore, and here this is basically the Kaimur ranges, which extends all the way into Bihar. Kaimur ranges. Then here you will observe the Karnataka Plateau. Here you will find the presence of the Deccan Traps. Here you will have the Telangana Plateau in this region. It is actually co-terminus with the Karnataka Plateau. So that is, here you will find the Amarkantak region in this area, the Amarkantak Plateau and the elevated area. So that is basically the spread. Here you will find the Meghalaya Plateau, the Karbi Anglong and the Shillong Plateau. So that is the spread of it. Okay. So again, I would request you kindly take up the atlas, take a look at the map of it, and try to find out what are the smaller divisions of the Peninsular Plateau. The more you look at it, the more sure you will get at it. And this year, you had a question which was asked from this simple image. You had a question which was asked in prelims. Let me see if I ask that question, how many of us we are able to make any clue of that. So I'll just give you the statement of that question, one of the statement of that question. So Sahyadris is the name given to Western Ghats in general. Western Ghats exist at the meeting point between Vindhyas and Amarkantak. A is true, B is false. I'll launch a poll. Let me know. So 34% of us, we feel that Western Ghats are situated at the region where Amarkantak and the Vindhyas, they end up meeting. So any clue where Amarkantak is, this is what I had marked, Amarkantak. That is why in the mornings, many of the times when the mind is switched off, it is actually better if you have a revision. I can see many of your minds are being switched off because just now, see, where are the Vindhyas? Here are the Vindhyas. Here is the Amarkantak. Do we have the Western Ghats in this region? Is it so? Do we have the Western Ghats in this region, or do the Western Ghats exist here? So that is how simple it is. Okay, so but still, nonetheless, please try to understand why you commit a mistake and get to the bottom of it. Only there the improvement lies. Okay, so these sorts of questions are framed from the area. You don't expect a question coming from this area in the prelims that tell me about cratons, etc. No, never. In the prelims, the question will be mostly a kind of a location based. Mostly it will be location based. Okay. Now we come to the eastern and the western Ghats. Why Amarkantak plateau is elevated? All these plateaus are elevated, and that is because of volcanic eruption, the ancient volcanic eruption which has happened. So now we come to the eastern and the western Ghats. So these particular plateau, whenever you talk about the Peninsular Plateau generally has a slope from west to east, right? So this particular sloping portion, which joins it to the plains underneath, that is the Ghat. Okay, so you have the eastern and the western Ghats. Both of them are in existence, but their formation and their feature are very, very different. When we talk about the eastern Ghats, they are much, much older. Ever since you had the Chota Nagpur and the Bastar Plateau coming together, since that time itself, Eastern Ghat formation had started to come into presence. So they are very, very old. And majority of the river systems you will observe, they are moving from west to east. So the Eastern Ghats have been eroded. Observe in this image, there is an absence of hills or mountains in this stretch, and even in the case of Mahanadi. So majority of the rivers, what they have done is they have eroded the Eastern Ghats because they are moving from west to east. And they are much, much older. So a region which is very old and a region which is newer. The height elevation has happened only around 90 million years ago or 100 million years ago. That is in the Western Ghats, and in the western portion, we do know that only when the Indian plate was moving over the Reunion Islands around 90 million years ago, it was at that point of time when the elevation happened. So there the elevation has happened only around 90 to 100 million years back. Whereas in the Eastern Ghats, the hill formation, etc., that has happened many, many years back, maybe billions of years back. So with passage of time, those have been eroded. The hills, the features, etc., have been eroded. So you will find very smaller features in the region of the Eastern Ghats. Whereas in the Western Ghats, still you will find the lofty escarpment. And that is why Western Ghats, that is referred to as an escarpment. Escarpment is what? We have studied that already in module 4. Escarpment is what? Escarpment is a steep wall-like feature created when there is a fault line which develops and another portion simply goes down. So that is an escarpment that is created. Now, when we talk about the Eastern and the Western Ghats, Eastern Ghats, I have told you, lot earlier formed. Now, let us try to understand how the aspect of Western Ghat section that we know, that the lands simply developed a fault and subsided, how it still dominates the present day feature across the Western coastline. So here, I'll show you the cross section. I'll show you the cross section here of the plateaus and the plateau region. So earlier, you had a situation somewhat like this. Okay. Now, when the crack developed and the land simply subsided, let's assume the crack developed here. Okay. Now, as the crack developed, this portion simply subsided. Meant what? It meant you would have a kind of a scenario somewhat like this. The Eastern Ghats obviously much lower and a gentle coastline. This portion came under water. This portion also came under water. Now the crack which developed, that portion sank underwater, formed a very wide continental shelf. Okay, the subsided portion. Okay, that formed a very wide continental shelf. And this is the escarpment that I was talking about. It is because of this steep wall-like feature that the western part of the Western Ghats receives very heavy rainfall because the winds are forced almost vertically upwards, causing very dense, very heavy rainfall. Now here, when you take a look at this particular region, here we can also gain some idea about the coastline. Now, across the region of the coastline, if you observe, let's suppose this is west, this is east. Across this region of coastline, overall, what will you observe? Water is going to be deeper immediately closer to the coastline across the eastern coast or across the western coast. Where do you think water is going to be very deep? Immediately closest to the coastline. West coast or east coast? Western coast. This is where water is deeper. Immediately next to the coastline, the water is deeper. And immediately next to the coastline, you require deeper waters. Why? For if you want to build harbors or ports, you need the water to be deep. Why? So that larger ships can come to the coastline. If the water is very shallow, larger ships will be somewhere here itself. Because when we talk about large ships, a significant proportion of their size lies underwater. So that is why these particular ships, they need to be, or they will come only in those areas where the water is deeper, closer to the coastline. And the event of subsidence, that has created a configuration of land like that in the western coastline. That is why you will find that the western coastline, they are much more favorable for the formation of ports and harbors. Natural ports and harbors, they are much more favorable to be present in western coastline. And please, as of now, don't have that, but here in the east we also have Chennai, we also have Paradeep and Haldia port, and you said only in western. I'm not saying only, I'm saying that western coastline becomes more favorable. In the eastern coastline, if you want to develop a port, you need to dig out a lot. You need to have a lot of dredging which has to be done. The deepening of the port needs to be done. Other than Vishakhapatnam port in the eastern coast, you don't have any other port city or port area in the eastern coast which can handle bigger ships. And even though we talk about Vishakhapatnam being a deep sea port, please understand, overall across the country, none of the ports have the ability to handle or the capacity to handle the largest of the ships of the world, the Panamax grade, the Panamax carriers that you have. So they cannot enter into Indian ports because it is not so deep enough. That is why government has been trying to construct a port in Virinyam in Kerala, but then there has been a lot of protest around that, so let's see if that gets completed or not. So that is supposed to be the only deep water port being developed across the country which will have that kind of a capacity. So that is why none of the ports as of now has the capacity to adjust the heaviest and the largest of the ships. Whichever capacity naturally is to be found across the western coastline. Okay, for the eastern coastline, if you have to get the same capacity, a lot of work needs to be done, a lot of digging out needs to be done. Colombo port is deeper, obviously, as compared to the eastern coast that we have. Colombo port has got a depth of around 15 meters uh, closer to the coastline. And that 15 meters can handle large ships. That is why very large vessels you will find, the large vessels, they will come from here, they will take a pit stop at the Colombo port and then move further east. That is where government has been trying to develop the Virinium port, which is going to be situated here. Virinium port has got the depth of around 22 meters. Panamax carriers can come here, and that will take the business away from Colombo port. But if the Virinium port gets completed, Colombo port is situated at Colombo. Have we no clue where Colombo is situated? Okay, that is a major issue. Not knowing Colombo port is not major problem, but not knowing where Colombo is. So it is in Sri Lanka. Okay, kindly look at Sri Lanka. How many of us have not taken a look at the world map ever in our life? That where is Sri Lanka? Where is Indonesia? I have no clue. For all those, please don't raise your hands right now. I understand it can be a bit daunting of a task. Just think about it, that you should please understand the examination that you are appearing for. Please understand, if you succeed in this examination, what is it that you are aiming to become? You are aiming to become an IAS officer, Indian Administrative Services or Indian Foreign Services. So think about it. Obviously, to make you an IFS officer, the government will at least have that much amount of scrutiny, that whether the candidate is aware of the capital of Sri Lanka or not. So have as much amount of knowledge enrichment at your own level as much as possible. Please don't always rely on, okay, this is the note circulated, this I will study, I will clear the exam. This is not your IIT JE preparation. This is not your graduation level exam. Realize the exam that you are appearing for, upgrade your level. Okay, now here the Western Ghats demarcates the westernmost extent of the Peninsular Plateau and forms an escarpment on the western slopes, thereby being able to influence rainfall across the western slope and the west coast. Now, It was formed due to the submergence of a part of land into the sea. Western Ghats are locally known by different names in different areas. So you have Sahyadri in Maharashtra, Nilgiri in Karnataka and Tamil Nadu, and Anamalai Hills and Cardamom Hills in the region of Kerala. Now, Western Ghats are comparatively higher in elevation and more continuous than the Eastern Ghats in general. But this is something we already know. The capital of Sri Lanka is Jayawardhanapura. Okay, fair enough. Present day capital of Sri Lanka is Sri Jayawardhanapura Kutte. But look at the location of it. Okay, other than the Wikipedia searches that you are going, look at the location. Where is Sri Jayawardhanapura Kutte situated? Find it out and get back to me tomorrow. So here, this is about the Western Ghats, known as Sayadris, Anamalai, Nilgiri, and by various different names. The Eastern Ghats, they run from northern Odisha through the Andhra Pradesh to Tamil Nadu in the south, passing through some parts of Karnataka. They are eroded and cut down by the four major rivers of the Peninsular Plateau: Godavari, Mahanadi, Krishna, and Kaveri. And some of the important ranges, Javadi, then you have Palakonda, Nalamala, all of these are parts of the Eastern Ghat stretches. And both of them will meet each other at the Nilgiri Hills. Okay, that is where the Eastern and the Western Ghats, they end up meeting. Okay, now after this, we come to the coastal plains, the most fertile feature across the Peninsular Plateau in general, because Peninsular Plateau largely consists of rocky features, igneous and metamorphic rocks. It is across the coastline, the coastal plains that you have, they are very, very fertile. And historically, even when you go through at the pages of history, you will find that these coastal plains, they have always been in contention. Various different competing powers have tried to bring that under their own control because of the fertility of the land. If you talk about the kingdoms of the Eastern Gangas, or maybe even the Cholas for that matter, the Cholas, the reason they could thrive so much was because of the fertility of the Kaveri Delta. And there they could grow multiple different crops at the same period of time. So that is basically the coastal plains that we have. Now, here, when we talk about it, these are named differently in different areas. So this entire portion, that is referred to as northern Sarkars. This particular portion is referred to as Coromandel Coast. Then the region in Odisha in particular, the Odisha coastline in general, that is also what is referred to as Utkal Coast. Now, eastern coast is much broader, much wider than the western coast in general. You'll find that the eastern coastline much broader. On the western coastline, you'll find that not only is it narrower, in certain areas, it is so very narrow that if you travel by train in those areas, you'll find that the Western Ghats directly meeting the sea in that region. So here also the naming is done. Here, for example, this is the region which is referred to as the Kutch and the Kathiawar coast. Kutch and Kathiawar coast. Then Ratnagiri southwards, you have the Konkan coast. Then here, portions of Karnataka, that is also referred to as Kanara coast. And then eventually, you have the very broad Malabar coast. Okay, these are basically the coastal features and the local names, the regionalization, if you can call. These are basically the regional areas across the coastal plains. Now, the when we talk about the eastern and the western coastal plains, here few of the differences. First of all, when we talk about eastern coastal plain, in childhood we taught that eastern ghats consist of hills. Yes, it is true. The eastern ghats, the western ghats, they will consist of certain hills in the process. Yes. And if we talk about west coastal plains, here, western coastal plains, it is a submergent coast. Submergent coast. That portion has submerged underwater. Whereas eastern coastal plains, over a period of time, they are an emergent coast. They have emerged above water. Now, when you will find that the land has emerged above water, has been underwater for some period of time, so what natural mineral or natural resource do you think will be available in those areas which have remained underwater and have emerged above water? Good. CaCO3, crude oil. Very good. So you will find a lot of crude oil. Now, in the region of the eastern coast, where do you find the crude oil? It is in the region of the Krishna Godavari basin. The Krishna Godavari basin is particularly rich in fossil fuels, crude oil, natural gas, all of them. Okay, so just by knowing the formation and the features, you will be able to have the economic connotation of that as well. So, eastern coastal plains, and then here, suited for harbors and ports, natural ports, and not suited simply. Then, broader, this is narrow western coastal plain. Then, extensive delta formation, extensive delta formation. No deltas formation, estuaries are found. Estuaries are to be found across the eastern coastal plains also. But across the western coastal plains, only estuaries are found and no delta formation. Why is it so? So, for no delta formation, you have a couple of reasons for them. The first reason is that, and think about it yourself, apply your logic that here you have the rivers which are coming to the portion of the eastern coastal plain. They form very large deltas, but such deltas are not created across this portion of western coastal plain. Think about it, and logically I'll come to it. I'll give you the explanation as well. So this is the broader difference that you will find in the case of eastern and the western coastal plains. Now here, which region is good for fishing? Almost both of them. It is a regional variation question. Not that the entire east coast or west coast can be taken as a kind of a homogeneous matter, but still you have many eco-sensitive zones situated across the western coastal plains. So you will have a broader variety there. Okay. Why we call eastern coastal plain as an emergent coastline? That is because over a period of time, this region, imagine that the coastal region was like this with the west coast and the east coast. Over a period of time, due to endogenic forces. And after the last ice age, it is estimated that this landmass has slightly elevated itself. This landmass has slightly come above. So many of the theories, they tell us that because you had a significant portion of land which underwent subsidence across the western coastline, so in order to balance that, you had a slight elevation. But then you have an elevation nonetheless. So that is why emergent, because it is emerging above the region of water. Okay, I hope that is understood. And because it had remained under sea, hence it is going to be rich in fossil fuels. Fossil fuels generally found or is formed where? Under the water, under the ocean, not the river water, under the oceans and the seas. So a portion which has emerged above will always end up having some amount of. That is why we have the oil reserves even in the region of Rajasthan, oil reserves in the region of Krishna Godavari basin as well, oil reserves in the region of Bombay High, oil reserves in the region of Ankleshwar in the Gujarat coastline also. So that is basically because of emergent. Okay. You talked about the Rift Valley system of Central Highlands. So is there a possibility that maybe after 100 to 200 years, India can be divided? Depends if there is a convection current inside. A convection current inside, so the African Rift Valley that you are talking about, that is basically a divergent movement has been created. Rift Valley in India is not so big. Rift Valley that you see in India, that between the Vindhyas and the Satpuras, they are very, very narrow, very small in general. So they are not created due to the convection current. They are created because of the folding and faulting, the Horst and Graben creation that we talked about, remember? So that is different in general. Yes, Raghav, that is correct. Correct, Shreyank. So western coastline naturally has got many ports and harbors. Kandla, Mazgaon, then JLN port, Navasheva, Marbagaon, Mangalore. You have various different ports which are situated. JLN port is the largest port in terms of the handling capacity that we have presently. There has been a massive expansion and upgradation of JLN port in the past few years, in the past decade almost. Now, western coast is divided into the sub-regional portion, that is the Kutch and the Kathiawar coast in Gujarat, the Konkan coast in the region of Maharashtra and Goa, and then you have the Malabar coast. Now, the coastal plain is broader in the region of the Kutch and the Kathiawar coast, is broader in the region again of Malabar coast. It is here that it becomes very narrow. Okay, that is where it becomes very, very narrow. Now, in the region of Malabar coast, you will also find that in certain areas, if this is the landmass, let's suppose, if this is the land, this is the sea, in certain areas, you will find that the sea water enters inland due to the presence of a low-lying region and forms a kind of a larger saline backwater. Okay, so that is something that you will find in lot of prominence across the Kerala coastline. A lot of backwaters to be present, where through the low-lying areas the seawater has come in, and then you have a tidal current, a tidal flow which is associated in those backwaters. So naturally, the backwaters or lagoons or kayals, they have saline water or salty water in condition because you have the seawater getting backward. So the middle and the western coastal plains, they are narrow in the middle and broader in the north and the south. No delta formation takes place. I'll tell you the reason. Malabar coast has got certain distinguishing feature in the form of backwaters which are used for fishing, inland navigation, and also you have the very famous boat race which is conducted across these backwaters. Which is the trophy? This is your general knowledge trivia, let me know. Which is the trophy which is awarded for that famous boat race of Kerala? Very good, Femina. Vishnu Maya, very good, Pravasini. You have the Nehru Cup, the Nehru Trophy, famously, which is awarded for that. Now, then Here, why no delta formation takes place? The first reason, the slope is from where to where? West to east, isn't it? So large rivers, they will drain from west and they will move to the east. So large rivers drain to the east. That is where you have regions of deposits. Then, secondly, does not mean that in the west you don't have large rivers which are draining. We have two rivers which are draining, not as many as across the eastern coastline, but here also we have rivers. Which are the two rivers? You have Narmada and Tapi. And why is it that Narmada and Tapi, they drain to the west and not to the east? If all the rivers are draining to the east, why is it that only Narmada and Tapi, they drain to the west? Beautiful. Correct. Very good. No, the slope is west to east. That is why all the rivers are draining from west to east. There must be something different due to which Narmada and Tapi, they drain to the west. And that is basically the presence of Rift Valley. Now, what is a Rift Valley? A Rift Valley is a kind of a structure with a depressed portion. So here you have the river which is flowing. Okay. Now, if a river, now think about it logically and get back to me with an answer. If a river is already flowing through a rift valley, do you think there will be vertical erosion carried by the river? Yes or no? Do you think there will be a large vertical erosion carried by the river? Yes or no? Good. The answer is no. Because already it is moving at a depressed region. Already it is moving at a region where the elevation is particularly low. So in that region, it won't carry any vertical down cutting anymore. So if there is no vertical erosion, why? Because the path has already been provided by the Rift Valley. So no vertical erosion means what? The amount of materials, eroded materials, will be very little. You need eroded materials to be and that is what you will deposit to form the delta. But if the materials itself are not brought by the river, why? Because there is no vertical erosion. Why? Because it is a rift valley through which it is flowing. So what you will have? No depositional structure also, and hence lack of delta. So here, no, Narmada and Tapi move through rift valleys. Yes, Lakshmi, that is correct. Some amount of erosion will always be there. But in large context, to develop a delta, you need large amount of erosion. That won't be there. Rift Valley, which means little eroded material, which means negligible deposition, which means no delta. Okay, that is why Narmada and Tapi, they will not end up forming any delta in the process. Rather, they form estuaries. Another minor factor here which is at play is the fact that western coastal plains are very narrow. You don't have much scope to slow down the river, slowly and steadily carry out the horizontal erosion as well, and then start depositing it. That much scope is not there. And across the eastern coastal plain, you have materials which have been carried by the vertical erosion, horizontal or lateral erosion. All of them are carried out, deposited in their due process of time. That is why across the eastern coast you will find deltas, estuaries, all of them are to be present across the eastern coast. But across the western coast, only estuaries are to be found. Okay, so that is basically the reason for no delta formation in the coastal plain. Eastern coastal plain, emergent coast, broader, well developed deltas are formed by the rivers known as the Coromandel coast in Tamil Nadu. Very fertile, much more fertile than the western coast. In fact, when you read history the next time, that is why I always suggest people that read history after you have studied geography, because that helps you understand the context, that why a particular kingdom was at war, why a particular kingdom wanted to take another region. So when you read history, let's suppose the next time, so you will observe that majority of the kingdoms who were fighting for the eastern coastal plain, they were fighting for it for the agricultural value of it, because it was so very fertile. But majority of the kingdoms who were fighting for the control of the western coast, you'll find that the fight or the battle was for the control of the trading lines, because the western coast natural harbors, so naturally they had supported a lot of trade. So historically, Western coast had been active for trade and economic purposes. So that difference you will find, and that differentiated many of the priorities of the various kingdoms. Look at the Cheras; their priorities were different. Rashtrakutas and the Pratiharas, they wanted those trade lines because they wanted to bring in horses, the modern grade horses in India. Whereas the Cholas, pretty much content with the agriculture produce, and they would expand it to Southeast Asia through the Bay of Bengal. So that kind of the geostrategy at play will be understood properly, I hope, next time when you open up the book pages of the book of history. Okay, now then, the island group and the formation. So when we talk about the island group, India is really blessed to have two group of islands, which increases our strategic depth, if nothing else, across the Arabian Sea as well as the Bay of Bengal. Now, across the region of Arabian Sea, we have the islands, that is Lakshadweep. Lakshadweep, we know. Lakshadweep. Lakshadweep basically, what is the literal meaning of it is basically a lakh islands which are present, right? The lakh islands, that is Lakshadweep. Now, how are these islands created? So these islands are of coral origin. And in fact, in this particular portion, again, I would want you to open up the atlas once. I will show you the brief map, however, but still I would expect you to open up the atlas. I want you to observe that this is the region of Lakshadweep. Now observe the light blue colors here. It extends up till Maldives and it extends further south, right? So in that entirety of the region, you'll find a lot of these islands, coral islands, which are created. How are they created? So you have many of the seamounts in that region. Seamounts which have been created due to underwater ridges, etc. And on those underwater ridges, the coral growth happened, and that coral growth led to the formation of the fringing reef, barrier, atolls, everything. So that is why Lakshadweep is of coral origin, as we have already talked about in the portion of oceanography. But when we come to Andaman Nicobar Islands, Andaman Nicobar Islands, they are created as a result of what? As a result of convergence. So here, Andaman Nicobar, observe this particular stretch. It extends all the way to the region of Indonesia, and observe that the shape will be very similar in the case of the Indonesian island as well. So this entire arc, island arc, is also what is referred to as famously the Indonesian arc. Now this Andaman Nicobar Island has been created as a result of convergence. Convergence of what? Convergence of the Indian plate and the Eurasian landmass. So when you had the Eurasian landmass, and you had the Indian plate. Now, Indian plate also will have the continental crust and the oceanic crust. Let's suppose you consider this as the oceanic crust and this as the continental portion of the Indian plate. Let's suppose. Now, as this underwent collision, we have talked about it that initially the collision happened across the northwestern extent. And after that, their plate swiveled and started pushing in the east because obstruction happened in the northwest. The entire plate started pushing into the east. As a result of that, the oceanic crust here collided and converged with the oceanic crust of the minor Burmese plate. So, Andaman Nicobar and Nicobar, you had oceanic crust of Indian plate converged with the oceanic crust of the minor Burmese plate. Which was earlier a part of the Eurasian plate itself. Okay. So this led to an oceanic convergence. Oceanic convergence. And whenever you have oceanic convergence, in that area, what kind of landforms are created? You have the formation of a trench. You slide a small amount of trench. You have the formation of seamounts. You have the islands which are created, volcanic eruption which get created, isn't it? So as a result of that, what can be the outcomes? The outcomes are volcanoes or volcanic islands, seamounts, trenches, etc. So Andaman Nicobar, you'll find all of these. In the region of to the east of Andaman Nicobar, you will find, or rather to the west of it, you will find a small trench also. That is the Andaman Trench, which has been created. You will find the volcanic islands. Which is the volcanic island present? That is the Barren Island. Barren Island volcanic eruption you will find to be present somewhere here. It is in this region where you will find the Barren Island volcano. Okay. So that is basically the entire formation of the region of Andaman Nicobar. And how is it that the Lakshadweep got created? Remember how we talked about that a portion or a seamount underwater which exists. So, for example, this lies underwater. We talked about it earlier that this is underwater. Let's suppose you have the presence of a seamount here. Now, on top of it, the corals will build up, the corals will develop, and they will utilize the previous calcium carbonate to grow in size furthermore. And eventually, what do we have? We have the coral island. On top of that coral islands, then the plants will come into existence. The animals will start taking shelter, rather, the birds will start taking shelter there. So you will have a lot of that formation happening. Okay, so that brings about the coral islands. A couple of islands in the region of Andaman Nicobar, they also have had a coral origin. Okay, so even in Andaman, you will find a couple of coral islands to be present, but Lakshadweep, Maldives, etc., they are completely dominated by these. Okay, yes, Barren Island is the only volcanic island present, only active volcano in India. Then this should be homogeneous and continuous. In what sense? And what should be homogeneous and continuous? Seamount basically refers to underwater mountain, Shoaib. Kindly look at the oceanography lectures. You will get a lot more clarity. So these are your island chains that we have. And now we get into the portion of the drainage system. Before that, we take a break. Okay, we'll take a break and then we'll be back and we will continue. So we'll be back when 42. We'll be back till 55. And then we will continue. A confirmation about the audio, please, guys, if the audio is clear and available. Thank you. So now we come to the portion of drainage systems. I didn't get, you said some parts of Karnataka is a part of. Yes, the very few portions in the easternmost extent, the southeasternmost extent of Karnataka, that is covered and touched slightly by the Eastern Ghats. Okay. So now we come to the drainage system. Now this is going to be relevant for your examination, both for your prelims as well as for your mains. So in the prelims, the type of questions that are generally asked based upon the pattern and the trend analysis, if you go by. So you will find few questions about drainage pattern, drainage patterns, major rivers and their tributaries, and also you have areas, for example, major cities. On river banks. Okay. And in the mains portion, you get more of an analytical type of a question from here. For example, features of the rivers. For example, flooding. In Himalayan rivers. For example, sometimes you get questions in the category which is very generalistic in approach. For example, that you will find that across the major river systems of the country, if we face water scarcity, what can be done to improve water security? So in those type of questions, you need to have a kind of a approach where you talk about all the factors that you know of which can conserve water. So water storage structures, construction of dams should be there. Water retention should be made a priority because rainfall in India is received only for 3 to 4 months of the duration. So generalistic question, they need an accumulation of all the content that you have. That accumulation has to be depicted on the answer paper. Then here, water scarcity. Then after that, you also find questions revolving around interlinking of rivers. Now, interlinking of rivers is one of those topics. If you ask the any of your let's say the older generation who has appeared for the exams in the late 90s, early 2000s, they will also tell you that interlinking of rivers was something that they had studied, that was important for them. If you ask someone who prepared, let's say around 2009, 2010, around that time, you ask them, they will also tell you they would have prepared a note for interlinking of rivers. If you ask anyone preparing last decade or so, everyone will tell you that this has been important. Even this year, many of the candidates, they came back and they told us that interlinking of rivers was asked in two of the cases I am aware of, that it was asked in the interview board, by the interview board, even in this year. So the questions are asked repeatedly. This is an area where question has been repeated multiple times, both for the general studies as well as the optional portion of geography. And you also have the panel members in the interview board. They also ask this question about interlinking of rivers. So these kind of analytical topics, these are basically so-called favorites of UPSC. For example, in geomorphology, the favorite area is the circum-Pacific zone, Pacific Ring of Fire. UPSC will ask you a question either this year, next year, year after that. Similarly, for example, in climatology, tropical cyclone is one of those favorite areas. In the case of when we talk about oceanography, ocean currents is one of those favorite areas. in terms of the drainage system, interlinking is one of those favorite areas. So questions keep on getting repeated. Now, here, when we talk about drainage systems, what is it that we exactly mean by that? Or what is it that we exactly understand by the aspect of drainage system? So in these areas, you have the flow of water in a particular direction, right? The flow of water and in a defined channel. There is a defined channel of flow, which we refer to as a river channel in general, where the water will flow in a certain set direction. Now, immediately after a landmass comes into existence, immediately after that, excess water, maybe in the form of snow melt or the melting of snow and ice and glaciers, or maybe in the form of, let's say, excessive amount of rainfall received, all of that will be directed towards the slope, and they will have a definite direction of motion and flow that they will be able to generate, that they will be able to produce. So, the drainage system is an outcome of the topographical features. You can frame it this way, that depending upon the topographical features, you can always determine the characteristic of the drainage features. For example, in any area, if let's suppose I give you the example of two different areas. One is made up of igneous rock. You have igneous, and another region is made up of sediments. Not even rocks, just sediments. Now, if I ask you, out of these two different land portions or these two different topographies, meandering of the river will be observed in A or will it be observed in B? Meandering is when the river takes a curvy path. That will be observed in A or B? Always B, isn't it? Because the water very easily will be able to flow and make its own path. Whereas in the case of A, if the water, let's say, is flowing like this, it won't be easy for that water flow to develop a kind of an erosional structure or develop a kind of a subsequent deposition whatsoever. So the characteristic of the topographical features, that ends up determining the drainage properties. So overall, the flow of water through well-defined channels is known as drainage, and the network of such channels is referred to as the drainage system. And these are governed by the topography of the land, the gradient of the land. If the slope is very gentle, the flow will be slower. If the slope is very steep, the flow will be massively quick. Okay? The geological time period when it is, that whether you have the newer rocks or the older rocks, they get eroded comparatively easier. So all these factors are responsible for defining the feature of any particular flow. And river basically drains the water collected from a specific area. So when you observe a river flow, the river drains the water from an area that is the catchment area, as it is referred to. So what is the concept of a catchment area? So suppose in an area, in a region, let's suppose we consider the mountainous terrain in a region. And here the river is flowing, coming down the slope and flowing. Right, let's suppose this is the land. Now, if this is what is referred to as the river channel, now, if let's suppose it starts raining in this area, now will it form its own independent river? That today it has rained in, let's suppose, any particular city, so it will have its own river from today onwards. No. What will happen to that water? That water will develop, an excess water will develop a kind of a stream, a seasonal stream or a runoff. and that will also merge with the main river itself, isn't it? Even if, let's suppose, there's a rainfall which happens in this area, even that water will be collected, will eventually then drain somewhere here, isn't it? So that is why if there is any amount of water from the entirety of the region, it will come into the river flow. It will contribute to the river flow. So that entirety of the region from where the river will accumulate the water through runoffs, through streams, etc., that entire region is what is referred to as the catchment area of a river. Okay, so a river drains the water collected from a specific area, that is the catchment area. So if you observe this particular image here, I want you to observe this. So here, look at the topographical features in this region and look at this, the catchment boundary. So even if it rains here or here, it will drain into the main river itself. Okay, it will drain into the main river itself. Now, meanwhile, if let's suppose you have an elevated portion and here you have a host of elevated areas in general, let's assume you have a host or a series of elevated ridgeline in a way which is present. Here you have a river which is draining. Here also you have a river which is draining from here, let's suppose. Now, if it rains here, let's name this river A, let's name this river B. If it rains in this particular portion, can the water in from this go to the river A? What do you think? If it rains in this particular portion, can the water go to A? No. Water will drain here. It will move to B. Similarly, if it rains here, the water will never be able to go to B. The water will be able to go only to A, isn't it? Why is it so? Because you have an uplifted landmass which serves as a kind of a physical boundary. Here you have the physical boundary. Okay. Now that physical boundary, which ends up separating two different streams, two different river systems in general, that is what we refer to as a watershed or a water divide. So this is what is referred to as, this physical boundary is referred to as watershed. Okay, that is what we have as the watershed. So drainage basins are divided from each other by topographic barriers called a watershed. That is a boundary line separating one drainage system from the another. For example, as we'll take a look into it, when we observe the Indus drainage basin and we observe the Ganga river basin, for example. Now, in the initial portion, Ganga drains in the direction like this, and rivers of Indus drainage basin, they also drain like this. But then Ganga takes a bend or a turn in the eastward direction, whereas Indus then moves to the south. So, Indus and Ganga drainage basin, they are separated from each other. They are not allowed to intermingle with each other due to the water divide which is present or the watershed which is present. And that is, what is a watershed? Very good. Beautiful, Shalu. So, it is Raghav, very good. Ambala, water divide. Separates the Indus basin from the Ganga basin. Okay. Indus water divide separates both of them. So that is what is the role of a water divide or a watershed in general. Okay. Now, there is a classification which is done of these streams, which is basically dependent upon the nature of flow. So any river, any stream, any runoff that you come across, you will come across one basic fact that the river will drain from a higher ground to a lower elevation. That is, from a greater elevation to a lower elevation, always. Have you ever come across a river where water is flowing upwards? Never. They will always be influenced by gravitational pull. But sometimes the streams or the rivers, they will give you an appearance as if they are moving against the slope. For example, if let's say you have the presence of mighty mountains, let's suppose. Now, if a river is moving like this, ideally, what would you expect? Would you expect the river to move like this, or would you expect the river to have a path like this in face of the topographical barrier that they have? This is the path A, this is the path B. So, which is the most expected path that the river will have? Obviously, most of you will adhere to the fact that the expected path should be B. But in certain rivers such as Indus, such as Satluj, such as Koshi, such as uh, Brahmaputra, in all these rivers, you will find that they end up following the path that I indicated, like A. They cross the Himalayas. The mighty and the tallest of the mountains, they are able to cut through them. So, in a way, it appears that they are defying gravitational slope. So, that is why you have the classification of the rivers based upon those which adhere to the slope of the land, which will give you the appearance that they are flowing and they are following the slope of the land. Those are referred to as the sequent streams. And you will also have those which appear to contradict the slope of land flow. That is the insequent streams. Okay. So these appear to follow the slope of the land. Appear to follow the slope of the land. Appear to contradict the slope. So we will take a look at it, that how is it that it appears to contradict the slope? How is it that something appears to follow the slope? That is very simple to imagine. That is very simple to see also. So we are going to take a look into consequent, subsequent streams, antecedent and superimposed streams as well. So starting with, first of all, the consequent and superimposed, consequent and subsequent. These are what are part of sequent streams. Streams here is something which has a similar connotation or a similar meaning like that of a river. So sequent streams follow the slope. Now, in this case, if you have, for example, without delving deeper into definition, understand this. If you have, let's say, the formation of very lofty mountains which have come into existence in a particular area, let's suppose. Let's suppose you have very lofty mountains in a particular stretch. Now, a river has originated from here, from this stretch. The river comes down the slope, eventually follows the slope, okay? So this particular river has developed immediately after the development of the slope. And they are following the slope of the land in general, isn't it? They are following the slope of the land. So these are the rivers which have come into existence after the formation of the topography, after the evolution of the topography, and then they have been following the slope like disciplined individuals and moving towards the sea. So this is what is referred to as consequent stream. Consequent stream. Stream, which is also referred to as master stream or master consequent. Example, river Ganga. River Ganga is an example of that particular stream which has come into existence after the formation of the slope of the mountain, and that has been following the slope after that as well. So that is the example of consequent. Okay, so streams that follow the slope of the land over which they originally formed. So direct consequence of the original slope of the surface where it developed. That is basically consequent. Okay. Now, meanwhile, suppose there is another river which originates from here. Maybe at the same stage, at the same time, or maybe at a later point of time. It originates and it ends up draining and then meeting this one. Now, this is also following the slope of the land. But here, it is joining the main river. Right. So that is why these are basically said to have developed after the main river has come into action, after the main river has come into existence, and they are following the slope of the land, but they are subsequent. What is the meaning of subsequent? The subsequent term is an English term. What is the meaning of it? Something which has happened after an event, right? An event has taken place, and after that or post that event you have another event which is taking place. So that is subsequent. So when we talk about subsequent streams, these are said to have developed after the master consequent, and they end up draining their water into the master consequent, even though it is very debated, because many geographers, you will find that they argue, and in certain cases rightly so, that this subsequent also ends up coming into existence at the same time. It might have come into existence at the same time as the consequent. So we don't know about the origin, but generally it is considered to be that stream which follows the slope of the land and joins the master consequent. That is subsequent stream. Subsequent stream. Okay. So that is the subsequent. I'll repeat again. What is subsequent? So subsequent streams are those which have originated either at the same time or a bit later than the consequent stream, which follow the slope of the land and then eventually end up joining the master consequent. That is what is referred to as subsequent stream. Example, Yamuna. Yamuna is an example of subsequent stream. Okay. Now, after this, we have the aspect of in-sequence streams. So when we talk about in-sequence streams, they appear to be defying the flow. So in-sequence streams. So they appear to defy the slope. To defy the slope. So you have two types of in-sequence streams. One is the antecedent and the other one is the superimposed. So what is this antecedent? Antecedent. Look at the meaning of it. And again, I would tell you that in the entirety of the portion of geography, at least, many of the times you come across certain phenomena which is not very clear immediately. Look at the English interpretation, English meaning of it. If you are able to figure out the English meaning, you will get the meaning of that feature as well. So antecedent means what? Something which has happened prior to an event, right? Anything which has happened prior to an event. So precedent, antecedent, these are the usable words that you end up using in your conversational English in general. So antecedent is what? So you have certain rivers which end up draining in a particular path, and then suppose the folding of the land happens at a massive scale, and we are talking about large rivers, not the smaller ones. The smaller ones, they can be blocked by the folding, but the larger ones, the mighty ones. So if let's assume you have a river system which is draining over a particular region, let's suppose this is a region where you observe a larger river to be draining. Now, if suppose the folding is initiated in this area, the land, suppose, starts getting folded. Now, as the land starts getting folded, what will happen to the riverbed? The riverbed will also exhibit a sign of getting folded. The riverbed will also indicate a sign of some upliftment, but the rate of upliftment is very slow. So the riverbed, what it will do is, it will get eroded because the river is flowing, the mighty river is flowing. So all around it, as the land starts uplifting, observe here, if this is the river, all around it, as the land starts to uplift itself, observe the riverbed maintains its flow. How? By eroding any uplifted portion in that region. So these are the rivers which appear to cut through these mighty mountains, and they come under the category of antecedent rivers. I will repeat. Antecedent rivers have been in existence before the entire folding of the landmass has been in existence. So let's say a river is moving through a region and the land starts folding in between somewhere here. Now the rate of fold, the rate of upliftment is very, very slow. So while the region around it is getting uplifted, the riverbed will continue to erode any movement across the river channel. Remember the concept that we studied in the case of incised meander and river terraces? I hope you recall that. So that same concept is at play here. So that is why massive rivers, the larger rivers, they are able to create very deep gorges. Observe the landform in this region. How will the landform appear to look like? Like a gorge, isn't it? So all around it, it starts to rise. The river continues to flow in its own original direction. So you will observe a kind of a gorge-like shape. River Indus, as it crisscrosses the Himalayas, the gorge created has got a depth from the top. If you measure the depth from the top, it is close to around 5,000 meters plus, which tells you That river Indus has been flowing in that region, and meanwhile, the land nearby it has uplifted and folded by 5 kilometers and more. River Brahmaputra, when it makes a southward bend near Namcha Barwa, it ends up carving a gorge close to around 7 kilometers in terms of its depth. So that tells you how these mighty rivers can carve out a very significantly deeper portion. So that is where here example you can take Indus, Satluj, Kosi, Brahmaputra, etc. Okay, all of this are examples of antecedent. And then we have superimposed. Superimposed. What is the meaning of superimposed? The English meaning. Something which has been imposed on top of an existing material, that is superimposed, right? So when we talk about superimposed drainage, don't look at the definition right now because you will get terribly confused. Superimposed drainage, if you observe, it will give you an appearance of a drainage system which, let's say, if it would have been present 3 million years back or 30 million years back, its flow would have been very different, its slope would have been very different. But because the river has come into existence now, the landform has evolved in such a way that the slope is very, very different. How? Let us understand that. The concept of superimposed. PYQs we had discussed on Friday itself, isn't it? This is after Friday. I think we are having the first class right now. Monday we didn't have the class, so we are discussing the PYQs. Or is it that you want to score good in the PYQs and you want to have that good feeling inside that, look, I have understood, and you want to have that kaun banega crorepati moment in your life where you mark an answer correct and you feel all the joy in your life coming to you, and then you get that confidence. Many of us, I have seen that we are waiting for the PYQs precisely for that moment. That, and even in the PYQs I've come across the fact that if I start telling you the answers of what should be the approach, people are not interested in that. What people are interested in, get us that polling option so that we are able to see what is the proportion of that scoring. So if that is the aspect, wait for it. By Friday and Saturday when we will have the extra session, I'll give you plenty of those feel good moments in your life. And by that I hope that the PYQs that we are going to discuss, you will be able to solve all of the portions of them, at least a majority of them. Okay, so here, coming to the basic concept. Okay, now here the superimposed drainage when we talk about, so apply your logic, get your logical antlers on and apply your logic here. Suppose I have a piece of land which has got a shape like this. Let's suppose. Now let's suppose this is made up of hard igneous rocks. Now at this stage, this is the hard igneous rock. If I ask you that where is it that a river would normally end up flowing? Would it end up following a path like this, let's say A, or would it end up following a path from here, that is B? Which is the more logical path that you think the river will follow if the river comes into existence at this stage? Good. It is going to be B, isn't it? If the river would have come into existence at this stage, river would have moved through B, maybe eroded the rocks thereby. So ideally, if I think about the rocks and the level of erosion, ideally, rocks here in this particular portion would be left almost undisturbed, and the rocks here would be significantly eroded if the river would have come into existence at this stage. But the river has not come into existence right now. There is no river which is flowing here. This is just to indicate the slope that the land takes. Now, let's say over a period of time, let's say 500 million years have passed over a period of time. And 500 million years have passed in the sense that the landform has basically evolved quite significantly, and the landform has had a lot of depositions in between. And all these depositions, they have gotten converted into softer sedimentary rocks. And the profile of the land has changed. So let's suppose after, let's suppose 5 million years, the land profile has changed ever so slightly. The base rocks are very similar in terms of their profile. Okay. Let's say on top of that, you have had a sedimentary rock deposit. Sedimentation has happened and sedimentary rock has been deposited. Sedimentary layer has been deposited and that has converted into a sedimentary rock. Now, these depositions have happened in a way which is like this. These depositions have happened like this. Now, these are your hard igneous rocks. And these are your softer sedimentary rocks. Formed as a result of deposits. Now, if I ask you the same image that I asked you earlier, that out of the probable places where a river can flow, if I give you the probable places, A and B, where is it that you will find the greater probability of the river to be flowing, A or B? Always in the case of A, correct? Because it is a low-lying area, river basically ends up creating a kind of a flow from a downward region in general, where the gravity will be in action. So A will be the probable area from where the river can end up draining, from where the river ends up flowing. Okay. So had this river come into existence, let's say long time back, 5 million years ago, river would have come or would have basically eroded structures here. But because the river has come into existence after the top deposits have been formed, the river comes into existence in this portion and the erosion will happen in this different region. Right. Now here, as the river is moving through its path, it will erode. It will have vertical erosion also in certain cases. So as it starts to erode vertically, let's suppose it erodes vertically. Vertically means downward erosion. So if it starts eroding vertically, it will erode here. And then what? The hard rocks also will get eroded ever so slightly here. So what do you observe here? You observe that the hard rocks in the region where they are slightly elevated, in that area where you have the crest of the hard rock, there it is getting eroded. Now, earlier, it was not even imaginable that the crest portion, the uphill portion of the hard rock would be eroded. It was not even imaginable, it was not even perceivable. But now, it is the uplifted portion or the uprise portion which is getting eroded. Why? Because above it, the landform which has developed, the softer rocks which have developed, they have initiated the flow of river in this particular portion only. So, regardless of the base rocks, the hard base rocks, the erosions continue. So, it appears as if the river system has got no connection with the slope of the base rock. It is driven by the surface rock itself. That is why superimposed on the base rock. So, in this case, it appears that the river flow is disconnected from the slope of the hard base rock. The flow is shaped by the surface deposits. This kind of a drainage, where the landform has evolved in such a way that the drainage appears to be disconnected from the base rock feature, that is superimposed. So now take a look at the definition aspect. So when a river flowing over a softer rock stratum, that is a softer rock layer, reaches the hard base rocks by the process of erosion, but continues to follow the initial slope itself, it seems to have no relation with the hard rock bed. Otherwise, if you have to consider the hard rock bed, it would not have flown in that region. If you have to consider the hard rock bed, the river would have or should have come into existence in this area as per the hard rock bed. But because there is a softer deposit of the softer rock, hence the river continues its flow regardless of what is the feature of the base hard rock. This type of drainage is called superimposed. It has got enough erosive power that it cuts its way through any bedrock, maintaining its former drainage pattern. Okay? So, now if I ask you the question, this kind of a drainage system will be observed in the newer landforms or across the northern plains or across the peninsula plateau. Where do you think? Newer landforms or older landforms? Very good. It will be observed in the very old landforms, which have undergone multiple different changes over a period of time. multiple different deposits have happened over a period of time. So generally observed in the region of Peninsular Plateau, Chota Nagpur Plateau, you'll find many examples of superimposed drainage. So that is where you will find it to be present in the region of Peninsular Plateau. Okay. So that is your superimposed drainage, where it appears that the river flow in general, it is not connected to the base rock. Because if it was connected to the base rock, river would have flown from here. River would have drained from here. But it is not. Why? Because it is now shaped by the topmost flow or the topmost surface that ends up determining the flow. So that is why the river, you will find, ends up draining here and has an erosional power in that region. Okay. Now, here observe this example. Look at the base rock. This is the base rock. It is a kind of an anticline, a crest. But because you have the softer rock here, the river will drain through here. Observe here, the softer rock gets deposited, the river drains through there. It will continue to erode the hard base rock as well, just because it is shaped by the topmost deposits of the sediments. So these are your drainage systems. Okay. But any river could do that cutting, right? Absolutely, yes. See, rivers individually, they don't have a superpower. It is the slope of the land, the evolution of the land, etc., which ends up creating these kind of drainage systems. If you give the slope, any river can do that. If you give that landform, any river can do that. Do you think that Indus, when it carves out a deep gorge, that is because Indus has got some superpower from the Almighty being above? Absolutely not. Indus is able to carve out a deep gorge because it has been in existence before that. And because it was a mighty river, massive river, because of melting of snow and ice. That is why, because you have a lot of flow of water, it would be able to cut a gorge. Put any other river in that place, it would also do the same. So it is basically a sum product of the topography and the relief features. Okay. So should we use different colored ink to draw these figures? Absolutely not. I don't think you have that much time while writing the answers. So try to write the answers on your own. You will get an idea about how much time is there. Okay. These deposits on the base rocks is due to exogenic forces. You have a lot of deposition and erosion. How do we know if there is cutting at the bedrocks at the base? By looking at the sides of the river. You get an idea about at what depth the river is cutting through. For example, if I take you to this one, if you observe the sides of the river valley, you will get to know that, okay, now the igneous rocks are coming up. That means the base rock is being eroded. Okay. Can we draw the diagram with pencil? Absolutely yes, my dear friend. Absolutely yes. Flowing below Bhabar is an antecedent? Absolutely not. Ain't it true that river is out of influence of older slope? Then why it said it appears? Out of influence. Where does it say it appears? In dunes formation are not antecedent? No, they are not antecedent. Okay. Example of superimposed. Take the case of Subarnarekha. You can take any of the smaller rivers of Peninsular Plateau. They will give you an example. Okay. The figure is clean, so you can also have that. With practice, you can also have cleaner images. See, half of the battle is won in an answer by your image, the image that you draw, not your personal image, because answer writing has got no scope for your personal image. So half of the battle is won by the images that you draw. Does not mean that you become an MF Hussain out there and you bring all the various weaponries, crayons, and pastel colors, and the finer pens and the glitter pens, etc. Because you will realize by the time you are done with two images and two answers, people are already moving ahead to the 11th answer. So let not that happen. Practice more, it will come into place. Okay. uh, right. Is Subarnarekha have gold deposits because of the superimposition? Subarnarekha, Sachin, has got gold deposits as a result of the phenomena of placars. Okay, right. Kishan, you said on mail that need to work on image and purified. The answer needs to be purified. That is basically the image should not give you an idea of disturbance when you are reading the answer. The images that you draw should give you an idea properly, and it should be neat. It should have a different font size when you are writing, when you are labeling the image. So that should be neater. And also, the purified aspect that I tell you in answer writing is the aspect in the many of the cases you will find that the answers, they consist of things that we know. Please understand the difference between them. It is a nuanced concept. Understand the difference. There's a difference between what is asked by the question and what is it that I know. If the question is about pressure belts and the wind systems, that needs to be addressed. Okay. The formation of the pressure belts, let's say I have talked about, then what do we understand by the wind system? So have a different heading, subheading as wind systems, underline it. The major winds, underline it, that itself. And underlining also, I have seen many of you, while you are underlining, I will just give you an example of this. Many of you underline like this. Whosoever does that, try to rectify it. Now, that is not what you underline. That is not the purpose of underlining. The purpose of underlining, if you have to, is basically, let's suppose, antecedent streams predate the upliftment of upland or mountain range. So, predate the upliftment. That is it. They have maintained their present courses through the continuous down cutting of their valleys. So that makes your answer much more crisper, because now the evaluator will, their eyes, his or her eyes will be basically locked in these key phrases and the keywords. That is something which should be your effort. In dune formation, river is not antecedent as the water. That is what I have been saying, Shalu. In dune formation, rivers, what is an antecedent river? Antecedent river is that river which has been in existence long before the folding and has cut through the fold. In dunes, does the river cut through the fold? Let me know. Uh, no, not in the case of dunes. Antecedent rivers that we have talked about, they cut through the flow. That is why when you talk about dunes are a land feature. Dune is not a feature of the river. Dune is a feature of deposit, of geomorphology. It is a geomorphic feature that you have. Is that understood or is it still not clear? In northern plains, we have more deposit than in peninsular plateau. That is correct. So, but when we talk about the northern plains, they are not very old, are they? So the landform has not evolved significantly. Whereas when we talk about Chota Nagpur Plateau, for example, it has got through multiple iterations, multiple evolutions, multiple deposits on top of them, upliftment subsidence. That is why here you will easily end up finding those rivers which are at a disconnect from the base rock. Okay. How much time should we spend in Atlas for beginners who don't have knowledge about any? On a daily basis, spend half an hour. Uh, okay. So, Shalu, is that now understood that what is a dune feature and what is the feature of the river? Antecedent rivers, you can have the rivers which predate the fold in general. That is something which can be regarded as antecedent, but antecedents, they cut through the folds. In majority of the cases, you will find antecedents, they cut through the fold, which is not in existence. And anyways, when we talk about dunes, in the case of the dunes, you don't have mighty and large rivers. You have very small rivers in existence, streams, and many of them, they are not even to be found now. Okay. Now, after this, we come to the drainage pattern. Pattern indicates what? The geometrical shape that we have. So when the river flows, as long as it has got a significant slope associated, it will end up following a kind of a straight path, right? So that is not always going to be the case. When the river flows in between the various different rocks, it ends up indicating different types of paths, different types of shapes. They are referred to as drainage patterns in general. So when we talk about drainage pattern, these are the river flow which happens where they take up different shapes. Now, what do you think will be the shape associated, or what do you think will determine the shape? The shape will be determined by the nature of the rocks. The type of flow, the geometry of flow will be determined by what? Will be determined by the shape of the rocks, the texture of the rocks, the nature of the rocks. For example, take this particular image. In this particular image, observe that as the river is flowing, here, in between these ones, the river cannot flow through there. Observe that all the tributaries that you have, they are almost parallel to each other, isn't it? Now, that is basically why. Because here you have hard rocks and then soft rocks in between. So the soft rocks are eroded, hard rocks aren't. So that is basically the drainage pattern. So let us make ourselves familiar with the various different types of drainage pattern relevant only for your prelims. All that you will be asked is, this is the feature, what is the drainage pattern that we are talking about? So starting with, first of all, the dendritic pattern. Dendritic, dendron. Dendron basically indicates the nerve cell, isn't it? And here, the nerve cell, if you look at the image of it, it is having a kind of a branching like the roots of a tree. So similarly, when you have a drainage, when you have a flow, and if the flow follows a random path anywhere, that is what is a dendritic pattern. Okay, it can flow anywhere and in any direction. That is a dendritic pattern. Now, when will it be observed? It is generally observed when the rocks have uniform, or when the region where they are flowing through, the rocks are uniform. So in those areas, whether you erode it here or here, it is one and the same. So there will be a kind of an equal erosion happening everywhere. So the river will decide its own path depending upon the slope and the gravity aspect. So this is observed in rocks or in areas having a uniform rock bed, so that equal erosion. Okay. Example, you have seen Indus, Godavari, Mahanadi, Kaveri, Krishna, Ganga, all of them, they end up indicating dendritic pattern. Then you have the trellis drainage pattern. Trellis, it is significant because of the shape that it has. And the shape is that the primary tributaries, that is the main tributaries, the primary tributaries are parallel to each other. They are parallel to each other. But if you take a look at the secondary tributaries, they are going to be perpendicular to the primary tributaries. So this is observed. Where is it that the primary tributaries, they will end up flowing parallel to each other? So that will be basically observed in those areas where, let's suppose, you have an alternate arrangement of hard rock followed by a soft rock structure. Then again a hard rock followed by a soft rock structure. Again a hard rock and a soft rock. So in these areas where, let's suppose, you have hard rocks followed by soft, followed by hard, followed by soft, followed by hard. So if here is where the river flow happens, let's suppose, then the tributaries, they shall find it easier to drain through these particular regions. Okay, tributaries will find it easier to drain through soft rock structure. Now, how is it that you will have the alternate arrangement of hard rock and soft rock? How will you come across this particular arrangement? So this will be an arrangement of both endogenic and exogenic processes happening. Endogenic can lead to the rise of the landmass, the unfolding of the landmass, and exogenic can level it off. How? Understand this. It is better to imagine. So if you are able to imagine, you will never find an issue in this. Suppose you have, let's say, the vertical cross section. You have alternate layering between hard, soft, hard, soft. Let's suppose hard, soft, hard, soft. Now, in this area, if let's say there is a compression, there is compression. What does that compression lead to? A fold in many of the cases. Not in all the cases, but in many of the cases. Let's suppose there is a fold initiated. And the fold happens somewhat like this. Let's suppose there is this folding which happens. Obviously, folding won't be uniform. Okay. This entire rock structure has underwent some amount of folding. Where you will have hard, and then soft, then hard again, then soft again, then hard again, here soft, here hard. Now, after this is the endogenic process which has created this. Now, after this, let's suppose there is an erosion. The land mass has been eroded. So when now the land mass is eroded, what is the landform that you will have? You will observe the alternate arrangement between hard rocks, soft rock, hard rock, soft rock. So it is in these areas where you will find the trellis drainage pattern in existence, where different hard and soft rocks, they have been folded and then eroded. So obviously to be found in the older regions automatically. So trellis drainage develops where sedimentary rocks have been folded or tilted and then eroded to varying degrees depending upon their strength. Primary tributaries of the rivers, they flow parallel to each other, and secondary tributaries, they join each other at right angles. Now, in old fold mountains of the Peninsular Plateau, particularly the Chota Nagpur Plateau, you'll find the presence of trellis drainage. In North America, Africa, almost in all the older parts, you'll find the presence of trellis drainage. Okay. Now, then we have the radial drainage. What do we understand by radial drainage? Before that, tributaries and distributaries. I hope we understand the difference between the tributaries and distributaries. So, the name in itself is self explanatory in a way. So, when you talk about a river, all those streams or rivers which end up draining their water into the main river, that will be referred to as a tributary. And then all those streams which would carry the water from the main river end up pouring it into the sea. That is a distributary. So this is just before the sea. This is your distributary. And this is a tributary. Okay? I hope that is clear. Now, then we come across the radial drainage. Radial means what? That it will originate from the central point. It would move outwards in different directions. For example, if you have to visualize this, observe this particular image. You have the central uplifted portion from which the river will originate. It will end up draining maybe in different directions altogether. So from one central portion, it is originating, moving in different directions. So from a particular hilly area, let's suppose. Yes, Prithviraj, that is correct. If you have a hilly area, from here, a river stream originates, moves in this direction. Another river, let's say, originates here, moves in this direction. So the rivers are originating from the same point. They are moving in different directions altogether. So that is a radial drainage. Radial drainage. Example, the Amarkantak region. Now, the Amarkantak region accounts for the origin of many different streams and rivers, in particular, Son and Narmada. Son and Narmada, they originate very close to each other. Narmada moves westwards because it drains through the Rift Valley. It moves westwards and empties itself into the Arabian Sea, whereas River Son follows the topography or the slope in the northern extent, ends up joining River Ganga. Right? So from the same region, you have two rivers following different slopes in different regions and draining in different direction. Now the opposite of this, radial, the opposite of it is centripetal drainage. Centripetal is the opposite of it when I say. Means what? From here, from the central uphill, you had rivers moving in different direction. In the case of centripetal, rivers will come in from all directions. Here you had the central uphill, there you had the central depression. So in the case of centripetal, small streams, they originate from all different directions and they end up accumulating in the region of the central depression. So it is significantly similar to radial drainage system, with the exception that here you have, let's suppose, mountains on all sides. Streams will originate from all different sides and they will end up emptying their waters in the smaller streams that you have, or rather the central depression that you have, the larger central lake which is created. Generally found in regions which are enclosed by hills and mountains, and you don't have large rivers draining into them. You cannot have a Ganga and a Brahmaputra draining their water into a central depression. That will be too much of water. So you don't have that particular phenomena. So always observed in the case of smaller streams, very small streams in general. So in the older depressions between the mountains, you'll find them. Okay. Now, it will lead to a large lake formation. Yes. Now, after this, we have the pinnate. Now, pinnate drainage system, it appears like a leaf, veins of a leaf in general. Now, when we talk about the leaf has got a shape. The veins, they have got a shape like what? Like this, isn't it? That is the shape that the veins of the leaves have. Now, the streams, they also have a similar shape. When do you observe this shape in the case of a stream? So when you have, let's say, a river which is moving, and on both sides you have mountains or ridges, for example. A river is moving through a region of maybe a rift valley or maybe from a central point, and on both sides you have mountains and ridges. So the small streams which will originate from these mountains or ridges, they will end up emptying their water into the central stream, isn't it? They will end up emptying their water into the central stream, and they will be coming down from a height, from a slope. They will join the central stream at a small angle. That is the case of pinnate drainage. So here, generally you will observe that the streams, the tributaries, they will originate from the lofty mountains or the ridges. Example, the image that you see, you have ranges on both sides. Okay. And here is where the river is flowing through. This is the main river. So from the high hills and the mountains, you have the small streams which originate and which end up joining them. So that is the case of pinnate drainage. It is very similar to a kind of a vein-like structure. Okay, Narmada indicates this kind of a drainage. This, okay, 500 meter, 200 meter that you are seeing, that is the elevation in general. Okay, so that is basically the pinnate drainage. Now, can a river exhibit multiple drainage patterns during its flow? Yes or no? Can a river indicate multiple drainage pattern in its flow? Yes, always yes. Keep that in mind, because the river ends up coming from a particular topographical feature, moves into another topographical feature. So it can always end up indicating multiple drainage patterns. And here, before we forget, one of the portions that I had asked that I will discuss after physiography, and that is the question which again UPSC has repeated multiple times in the portion of Indian geography, and that is, why does the Himalayas experience more landslide than the Western Ghats? The Himalayas, why do they experience greater amount of landslides as compared to the Western Ghats? UPSC has twisted this question left, right, center, but the crux is always the same. I want you to get me the answers. Okay. So the first, it is an unstable slope, right? Why? The landform is still evolving. Evolving. The slope is still evolving. Secondly, seismically active. frequent earthquakes, they loosen the materials which can come down, frequent earthquakes. Then after that, the slope is steep and very high. Western Ghats are not that high, are they? Western Ghats are particularly less in height. These are significantly very high. Then unconsolidated structure, easy to fall down. By the way, what is the meaning of unconsolidated? We have already talked about it. So, a quick recap. Unconsolidated means there is no particular layering. You can have larger rocks above the smaller pieces. So, the larger rocks won't have the stability. It will always have the tendency to tumble down. Okay. So, this is Ghats, Western Ghats. Then, after that, large number of rivers and streams. Then after that, large number of rivers and streams makes the water abundant in that region. Then after that, you will have lack of vegetation cover. Western Ghats is densely forested, so it binds the soil. Lack of vegetation cover means loose topsoil. Then after that, in this case, rivers here move with high velocity, high speed movement. Then increased frequencies of cloudbursts, of cloudbursts. Okay, there will be increased frequencies of cloudbursts which will further initiate the movement. Then after that, unsustained infra construction, infra building, then tourism. Both of them leads to weakening of the slopes. Of slopes. Then after that, more or mining activities, especially in the northeastern region, slope weakening. Okay. Then, so these are your major factors. So here you have 1, 2, 3, 4, 5, 9. 9 basic points. You can always end up elaborating 2 to 3 sentences from each of these points. Okay, I hope so. So that gives you an answer and an ability to write even a 250 word answer if it is required. Unconsolidated rock structure basically refers to the fact that you don't have a layering, that large rocks at the bottom, smaller rocks at top, then smaller rocks. In the slopes, you will find that on top of the smaller fine sediments, you can have larger rocks. And those larger rocks will never be stable. So they will always have a tendency to roll down. And why is that the case? Because much of the slope formation and the slope demarcation is done because of the flow of the rivers in itself. Okay, right? Eighth point, unsustained construction that has been stopped in the case of the Western Ghats. Last point is mining activities. Mining activities where you mine out the various minerals which are present in the mountain. So you use a kind of an explosive device. So that weakens the slope. Okay, so in the region around, when you talk about the northeastern region, many areas of Arunachal also, and in the case of the eastern Himalayas, many of these regions are being mined. Yes, that is correct. Is that understood? Snow movement in certain cases, you can. The snow melt, you can write in certain cases. Certain isolated cases, snow and glacier melt. Unsustained construction means construction which is unsustainable. Okay. Now, after this, we come to the portion of the river systems. So, when we talk about river systems of India and the various forest paths, you have to understand that river systems have always been important and relevant. Rivers are typically referred to as the cradle of a civilization, or the regions where the civilizations they are born. If you take again, when you read history, you will come across the Egyptian civilization, the Roman civilization, the Mesopotamian civilization. All of them developed on the sides of the rivers. The Harappan civilization. Now, Harappan civilization developed across River Indus. Mesopotamian developed across which rivers? Euphrates and Tigris. And the Egyptian civilization developed across River Nile. So you had the rivers forming the backbone of civilizational development. Why? Because they solve multiple purposes. They provide drinking water, essential for survivability. They provide water for the growth of plants or the crops, cultivation. They give you water to take care of your animals. And they allow, the least of all, transportation facilities. Now, that is why they have been very, very useful. In fact, as late as during the Mughal Empire, you had the royal household as well as the royal army, which would march or which would move very swiftly with the help of the rivers. The next time when you study the battle between Humayun and Sher Shah, the Battle of Chausa, observe, or you will get to know about that also, that because a sudden attack was mounted on the Mughal camp, the royal household they had to evacuate the battlefield with the help of the river. So river movement has always been instrumental. In fact, one of the reasons that the Magadhan Empire, the ancient Magadhan Empire, was so mighty and so powerful is because of the location of Patliputra or Patna. Patliputra was situated at the confluence of the rivers. And that is why Patliputra was famously referred to as Jaladurg, or the water fortress, where it was almost impregnable from all sides because rivers would surround it, mighty rivers, the rivers which would carry large amount of water. And also, it was easy for the army to move in any direction, northwest, east, south. So that is how instrumental they have been. But for the past 150 years or so, particularly in the case of India, there has been a general impoverishment of the artisans, impoverishment of the population in general, due to which the standard of living has declined. People now are in a status where they are extracting and exploiting the river water. The river water in many of the areas that is suffering from the solid dump waste that we generate. Because many of the people you would have seen, they go to a river to have a normal sighting of the river, right? They will sit on the river bank, and this is something which is prevalent across the country. Here, there is no kind of a classification that North India behaves a certain way, South India behaves a certain way. No. North, South, East, West, we are bounded by the same sense of stupidity all around. You'll find that many people, you go to a river bank or a kind of a dam like a storage structure, they will consume some eatables, some chips, etc., wafers, and they will throw the wrapper or the plastic there itself. Why? What is the thought process? The thought process is river will carry the water. Who will tell if I have thrown the waste or XYZ has thrown the waste? Not accountable. So we have done this. And we have been doing this and we are doing this, due to which the flow of the river has been impacted. The amount or the property of the river has been impacted. And that is why we are facing water scarcity in different parts of the country. Now, here, what is it that we are going to study? We are going to study about the rivers in general across the country, north, south, east, west, their major tributaries, and we are going to study about the interlinking. So, how do you classify the rivers? When you classify the rivers, when you classify anything, what is the purpose of classification? The basic purpose of classification of any aspect is that you should have an idea about the properties of individual types separately. Properties should be understood. Now, classification can be of two types. One classification can be of rivers draining into Arabian Sea, and the other for the rivers draining into Bay of Bengal. But there, this is not a homogeneous classification. Because when you talk about rivers draining into Arabian Sea, you talk about river Indus, you talk about Narmada, Tapi, maybe a Mahi or a Sabarmati, right? And when you talk about rivers draining into Bay of Bengal, you talk about Ganga, Brahmaputra, Krishna, Kaveri, Mahanadi, Godavari, all of them. Now, do all of them share the same property? A Brahmaputra is very, very different from a Kaveri. A Mahanadi is very, very different from a river Ganga. So that is why classification is done based upon where the river ends up originating. What is the origin point of the river? That forms the basis of classification. So on that basis, we have the classification as the Himalayan rivers and the peninsular rivers. Okay, we know the properties in general, but by the way, one trivia by this map. That is why I want you to explore the map, not learn the map. One trivia is River Mahi. Why is River Mahi famous in terms of the physical aspect of it? It is the only river in the country to be crossing Tropic of Cancer twice. Very good. It is the only river which cuts Tropic of Cancer twice. Okay, so these trivial pointers you need to remember. How to remember the origin of the river? Any tricks? No, my dear friend. I'm not the individual who believes in tricks or various different mnemonics. You will find many of the content filled in YouTube with a kind of any kind of mnemonic that people think about any aspect. They start learning that with that particular perspective in mind. I'm not the one who will advise that. I never advise, but you are free to follow any mnemonic that you develop. Ideally, what I would say is, if you learn the rivers like that with the help of the mnemonics, you are doing what is expected out of you in class 7th, right? You are rattofying it. The moment you rattofy anything, you leave a lot of scope for mistakes to happen and a lot of scope for yourself to be surprised in the exam. The moment you move across this particular aspect in an organic manner, slowly and steadily, understand it, there is very little scope for you to reach the exam hall and then be suddenly surprised. Okay, I had learned something like uh, any kind of a mnemonic, and if something is misplaced in between, you should not feel out of place. But that is my own suggestion. You are free to follow your own mnemonics, and I have had candidates who develop their own mnemonics and they feel comfortable with it, so it is up to you. For this particular chapter, I would suggest to you, I would advise to you, generally this is an unpopular advice amongst the candidates, so let me issue the caveat. First of all, I would advise you to have a lookout for the current affairs. For example, all of you appearing for the exams next year, before you appear for the exams, there will be a next state of forest report which will be generated. I want you to go through that. I want you to be aware that which river is in mention in the news. Okay, does not mean a question will be asked from that river. A question might be asked from the tributary of that river, or a tributary is in news, maybe the main river can be asked. So always keep an eye out for the current affairs. So what portion do you have to look out for the current affairs? Names of rivers in news and streams in news. Names of storage structure. For example, right now in Karnataka, Almaty Dam is in news because of a lot of solid waste dumping, which has reduced the water level. So those things that you come across in the news. Names of cities in news on the banks of river. I'll tell you the name of the report tomorrow, Lakshmi, as we study about the report. Yes. Can you send current affairs regarding this topic in my email ID? Amongst the most interesting questions that I have come across. So, what do you think? What is your general expectation, my dear friend, when you were typing this question? I'm sure you would have had an expectation. So, what was your expectation? That on a daily basis, whatever portion of current affairs comes up, some individual will uh, have a compilation of all those, and then they will find out who to be sent, and they will send it to you for the river. What about the current affairs for polity, by the way? And what about the current affairs for economy? Do you need a separate mail for that, or will the same mail do? Do you need a separate mail to be addressed for current affairs of polity? Environment also is important for current affairs. Please never get habituated. If you want to clear this exam, please don't have this kind of an expectation that someone will create the notes, some other person will do the proofreading for the notes, some other person will tell me what is important. At the end of the day, I will ratify it, I will learn it. Somebody should tell me how to write the answer also. Somebody should fill the application for the prelims for them, and should ensure that I clear the prelims, should ensure. Please don't have that expectation. Do this basic. Please understand the examination that you are appearing for. Okay, 5 lakh or people will appear for this exam, 700 will succeed. If this exam would have had such a shortcut that I would give you the notes, you learn from those notes, you clear the exam, it would have been a different ball game altogether. Okay, so please never have that. Okay, and that is why I did not take your name in this. So I hope you have that kind of an understanding. So that is where we'll end the session here, guys. Today we'll take up a few questions now, and then we will be done with it. What is the subsided portion of the land Western Ghats called? Continental shelf. Um, then Hariom, exactly my point. Ashwant, lithium reserves are to be found in the region of Karnataka. the Mandya region of Karnataka, and recently they have been found and discovered to be present in the Riyasi district of Jammu and Kashmir as well. By the way, the prelims results were declared yesterday. I hope that many of you would have had your friends or colleagues who cleared that. A centripetal is like a tributary. A centripetal is like a collection of small streams happening in the central portion, in the central depression. Uh, I started reading off newspaper from tomorrow. Continue that. Reading the newspaper is a habit that you develop only after 20 to 21 days of being regular. Do that on a regular basis. Then the monthly magazine should be used as revision. How gear ranges have been formed. Madhvi, so gear ranges also have been a result of a slight upliftment and a fold which has happened. And at one point of time, the entirety of the portion of the gear ranges that you see, they were separated from the Indian mainland. Gujarat, the region of Gujarat in general, was not there. You had the presence of small islands of sort which had mountains that present day we see as gear ranges. You had shallow water body, and then you had the rest of the country. So, if, over a period of time, due to deposits made by the streams coming out from the Aravalis, the fall of the sea level, etc., that created the entire plain region that you observe in Gujarat. Okay. Subhash, that would be enough. See, the perspective of reading should happen. Okay. How dumping of waste can slow the flow of water? It will basically, in a way, form an obstruction. Lot of waste dumping. So observe in the cities, the speed of the water is not significant. The speed is almost negligibly slow. Why? Because there is too much of waste which has been dumped. Okay. Yes, Shivani, more than sufficient. Uh, How were the rocks arranged in hard and soft? So, by the result of deposits, volcanic eruption subsequently, that can always happen. Vanshika, if I attend YouTube's current affairs lecture of Byju's and CNA, is it enough? Or I read newspaper also? So, let me make myself very clear. See, if you just want to clear the prelims for the sake of clearing, give a good fight in mains, and that is the life, that is the aim of the life. More than sufficient what you have said. If you want to get a rank in top 50, if you are excited by looking at the toppers list, and if you see yourself somewhere in that toppers list, please start reading the newspaper. Newspaper reading has multiple effects. Okay. Current affairs is just one of them. Answer writing, vocabulary, understanding skill, reading skill, perspective, all of that will come with newspaper. So, regardless of whether, as I have multiple times I have reiterated, even if the prime minister, the cabinet secretary, the chief editor of Hindu, N. Ram himself, everyone, if they call you in early in the morning and they tell you the news headlines, still I would suggest to you to read the newspaper. Okay. So newspaper reading is that very much instrumental. It will give you the confidence to tackle any question. And trust me with this, all of you, I'm sure many of you are not reading the newspaper. Do this in your life. For the next 40 days, just read the newspaper on a daily basis. You will observe that your confidence level takes a next stratospheric jump. That is very essential, my dear friends. Okay. And for reading newspaper, lot of time initially will be observed, will be taken, but it will reduce. So what do you read in newspaper? Don't read the political articles. Mamta Banerjee has said this, prime minister has said this, chief minister has said this. Don't read these political news at all. Read the news and how to weigh whether a news story is important for exam or not. Any topic which is relevant today, which can be relevant 1 year from now, and which will be relevant 1.5 years from now. That is relevant for your exams. For example, governor has taken an action which is challenged in the court. That can have long-term implications. There has been an issue in election, long-term implications. El Nino, weakening the monsoon, long-term implication, right? For example, GDP growth, short-term implementation, relevance. But the factors which contribute to it, long-term implication. So international relations, long-term implication. So always follow just these news headlines. Slowly and steadily, it will have a better outcome for you itself. Kirubaga, you can follow the analysis of those articles which you find difficult, or just to get a perspective of it. Use those CNA articles and CNA pieces as a point of revision, if possible. Okay. Kishan, denudation is also a reason for Himalayan landslide. Yes, always. Due to caldera, centripetal pattern can form, generally not. No. There are a lot of tributaries of many rivers. How can I learn and understand in a better manner? My dear friend, this is something which should be attacked at. Current affairs. And we just need to check articles by ourselves, or just given in daily at 9 a.m. is enough if we study those mentioned. So those articles that you see mentioned in the Telegram, you should definitely read that, but you should browse through maybe an app, maybe the e-paper, maybe the hard copy, anything. You should browse around yourself as well. Many of the times, trust me when I say this, questions have been asked from the images that you find in the newspaper, the images of a tribal dance happening. Now, UPSC is not going to ask you which tribal dance was there in the Hindu newspaper on 25th of October. No. It can have a question from the festival associated. Now, the candidates will be left scratching their head. Why and how this festival was asked? It was asked because it was in current affairs. So, that is where you maximize your return. Okay? Yes, absolutely, Rahul. Jyoti, DNA by cover 10 to 11 and current affairs. Um, See, I'm not going to say it is not enough, but just by doing things which are enough will not get you through civil services. It is something which will get you through the state services, lower grade examination. But civil services, my dear friend, I hope you want to become an IAS or an IFS officer or an IPS officer. So for a general candidate, you need to get your rank within 200, right? Within 150 to 200. And getting that rank, it is not impossible, but you need to do something which is out of ordinary. Everyone, they find it very easy. Go to Delhi, go to any of those areas, everybody will be following analysis videos. Newspaper reading, very essential. Okay. Changes, set yourself a short term and a long term target, keep fulfilling that. And Ashwant, because my number was not in the list. Ashwant, don't worry. It happens. Prelims is something which was very difficult this time. Understand where you did your mistakes. Give yourself 4 to 5 days. Analyze the mistakes that you did. Divide the mistakes into the lack of concept, lack of concentration. Lack of concentration will be improved. Lack of concept has to be improved. So start revision as soon as possible. Okay. It means river through any of the gorges happen to be antecedent, not always Pulkit. This year prelims paper on geography is from deep mapping. Not, no, very simple mapping. Shivani, if you get in touch with any of the candidate who has attended the geography sessions for the previous year, we had predicted the regions of Nagorno-Karabakh. We had predicted the regions around the area of Ukraine, the bordering areas of Ukraine. So these are the regions that were easily predicted. So that is why there is a kind of a pattern to the madness that you see. Yes, Madhur, just keep on following that as of now. Ritika, your question, let me find your question and then I'll end it up. Uh, Anu, shall I take 4 to 5 months? As of now, Anu, try to have a kind of a confluence with the examination preparation, because generally the government sector jobs, they are not that strenuous. But if you find it incredibly difficult to manage, you will have to think about a sabbatical or something, but not always. Sports area should also be read. You should have a general clue about it. You should not be completely averse. Asif, I didn't clear prelims this year. It's okay, Asif. First of all, understand that you have appeared for the examination, which was your dream. There has been a failure. There is bound to be failures in the way. And now you are a much more informed individual. Now, suddenly, you would find a level of maturity coming into you, which was lacking maybe a month back. So, now when you approach a new area, how to approach that area, you have to understand, revise as much as possible, be very regular with current affairs. Okay. So, for any other issues, please feel free to contact me. You have my mail ID. We'll get back to you. And till we meet again, take care of yourself. Goodbye. Thank you.